Among all the planets of the solar system, our Earth is unique, since it's the only one that has developed life. But what if we got a competitor? What if a second Earth appeared out of nowhere? Then there would be two different scenarios. The first is the destruction of both planets. The second has an unexpected but pretty logical ending. But let's start with the catastrophic scenario. The second Earth with the same conditions could only exist if it received absolutely the same amount of sunlight as our planet. The orbit that our Earth follows is perfect for getting the necessary amount of solar heat. If we were a little further away, the entire surface of our planet would resemble Antarctica. And if Earth were a little closer to the sun, we'd all live in a huge desert, inhabited by very few living beings. So, for the second Earth to be identical to ours, it would need to follow the orbit of our planet. Two massive objects can exist close to each other. The union of Earth and the Moon is a great example. But if the second object was as heavy and huge as our planet, there wouldn't be enough space for both of them. The gravity of two Earths would be a huge problem. The two worlds would collide because they would be pulled toward each other. This process would last for hundreds of millions of years. And in the end, the two planets would transform into one giant world. And their remnants would be flying around the newly formed planet, resembling the rings around Saturn. Or one of the planets would push the other out of its orbit. In this case, one of the Earths would hurtle toward the sun and burn like a match in its atmosphere. It's also important to remember that Earth is moving at a speed of 67,000 miles per hour at all times. This is more than 80 times faster than the speed of sound. And now, imagine two huge planets that are flying toward each other at such a speed. Even a microscopic organism living in the mouth of a volcano wouldn't stand a chance to survive the collision of two Earths. Even the Moon would be torn to pieces by the blast wave. But let's imagine that Earth's twin is following another orbit, somewhere between Mars and Earth. Even in this situation, people's lives would change forever. By the way, the theory that Earth might have a twin appeared long ago. Scientists of the past believed that the second planet could be hiding on the opposite side of the sun. Thanks to modern technologies in astronomy, we know this theory isn't true. Otherwise, our telescopes and other equipment would have already caught some signals from this planet. Scientists study space objects thousands of light years away from us, so they would definitely notice another world in the neighborhood. But anyway, let's imagine that the second Earth does exist, and we've discovered it recently. The entire field of astronomy and astrophysics will immediately receive hundreds of billions of dollars in funding. The study of Earth's twin will become a priority goal for people. Experts will put forward hundreds of hypotheses about what the second Earth looks like and what's happening there. The planet is almost at the same distance from the sun as we are. This means the weather must be the same there. Soon, scientists find out that Earth's doppelganger has liquid water and continents, but they aren't like ours. Their shapes and location are different. Most likely, life exists there too. But what is its origin? There's a hypothesis that life on our planet appeared thanks to amino acids brought here by a meteorite. It's highly improbable that the same thing happened to another world. Life most likely emerged there in a completely different way. Perhaps the fish didn't get out of the water on that planet, and the first intelligent creatures appeared in the ocean. These could be amphibians with scales and fins, or octopus-like monsters with huge tentacles. Fish on the second Earth could have come out of the water and grown limbs. But what if they didn't like walking on the ground? Then, this world might be inhabited by intelligent bird people. Or, life could have originated deep in the soil. Then evolution would create humanoid moles or highly developed worms. To find out for sure, scientists send a rover there. A similar mission to Mars was a success, so there shouldn't be any problems with this one. People on Earth are waiting. What will the rover find on the other side? It will take several years for the ship to get there. Strangely, 2 days after the launch, it returns. But wait, this is not our space probe. All this time, the inhabitants of the second Earth have been watching our planet too. At one point, they also sent a probe. It's made of the same materials as ours. It has a camera and a recording device. But people are worried because the rover looks similar to a mechanical spider. Can it be that giant tarantulas live in that world? Scientists understand that we need to communicate. We send our guests a radio signal with some information about our civilization. They catch this message and send their own. It contains strange symbols that resemble scratches. Linguists all over the world are trying to decipher it. Meanwhile, astronomers send the guests a recording of human speech. A few days later, our satellites catch a message from our space neighbors with their voices. Scientists are about to play the recording. The whole world is listening with bated breath, and it's a growl. A terrible and absolutely incomprehensible growl. It has pauses and an unusual rhythm, but it's nothing resembling human speech. The whole planet is panicking. All countries are preparing for an invasion. The most important thing now is to build shields to protect the planet. No one can decrypt the message. It's possible that our neighbors can't understand us either. People make a last attempt to establish some contact. We send a video to explain to our guests with the help of gestures and signs that we only want peace and collaboration. The answer doesn't take long to wait. Our satellite receives their video file. Scientists play back the recording, and it's shocking! We see dinosaurs in robotic suits! Life on the second Earth has been developing in the same way as on our planet. But the infamous colossal meteorite didn't fall there. Over millions of years of evolution, dinosaurs have become sentient. In the video, they're growling and pointing with their claws at the picture of our Earth. Then they start growling even more loudly, and is it laughter? The recording ends. People consider this the announcement of the invasion. Several years have passed. During this time, scientists have exchanged messages with dinosaurs several times, and it seems we're beginning to understand them. It turns out that the reptiles also want peace. They say that their planet was once inhabited by humanoids similar to humans, but a massive flood wiped them away. Dinosaurs managed to survive and evolve into intelligent beings. It will take many years before people set foot on their planet, and when this happens, humanity will feel relieved, realizing that we're not alone. But what if there was no intelligent life on the second Earth? People would also be happy. We would know that we'd always have another home. Perhaps we'd start exploring Earth's twin right away, or begin mining its resources to replenish ours. In any case, our lives wouldn't change immediately, because that land would be too far away from our planet. Dozens of generations would pass before people begin settling on the second Earth. Our homeland planet would be losing more and more resources, so everyone would want to move to a new world. In the beginning, only the richest would be able to do it, but with time, space travel would become cheaper. People would probably invest a lot of money to build a paradise on the second Earth. If this happened, we'd be visiting this world during our vacation to breathe fresh air and enjoy nature. In any case, the human population would grow. This means that sooner or later, the second Earth would become as loaded as the first one, and then people would start searching for a new home among the stars. By the way, if any life exists on a planet similar to ours, it's likely to look like octopuses. There's even a theory that octopuses came to Earth from some other world. Any animal has several evolutionary stages of development. For example, elephants and mammoths descended from one common ancestor 5 to 6 million years ago. Looking even further, almost all mammals evolved from one ancestor they shared with reptiles. Each species has been changing over millions of years. But not octopuses. They suddenly appeared on a family tree. From the point of view of evolution, squids would have to evolve into octopuses millions of years from now. But look, they're already here. Besides, octopuses are incredibly smart. Their genetic code is much more diverse than the human one. They may be visitors from another planet that is similar to ours. But of course, this is only a hypothesis.
The search for ET is on. It's most definitely on. With the successful launch of the James Webb Telescope, the search for Earth-like planets has become a riveting topic of worldwide attention. Apart from the James Webb Telescope, other tools are being used to find good Earth-like candidates. The TESS satellite and the Kepler telescope are at the forefront of searching for other Earths. After we first clear the air of a few pesky philosophical questions, we'll take a close look at these two searches and what the James Webb Telescope hopes to find. So, why are we searching for Earth-like planets? Well, because we can. Incredible advances in Earthbound telescope technology have enabled ultra-precise observations of starlight, which led to the earliest discovery of exoplanets. As planets go around stars, there's a gravitational interaction between the planet and the star. They pull each other. The planet's pull upon the star will cause the starlight to wobble back and forth ever so slightly as the planet or planets orbit the star. This has always been the case, but the wobble of the starlight was never able to be detected, because starlight always twinkles. You know, twinkle, twinkle, etc. Adaptive optics inside telescopes is the technological breakthrough that first enabled astronomers to find exoplanets by taking the twinkle out of starlight. Mechanical springs on the underside of telescope mirrors bend the mirrors ever so slightly to neutralize the distortion, the twinkle, caused by starlight passing through Earth's atmosphere. Without the glimmer of starlight, the slight wobble caused by planets pulling gravitationally on the stars is observable. The bigger the wobble, the more planets. It's called the astrometric method of exoplanet detection. Isn't that a mouthful? Whole star systems and literally thousands of exoplanets were inferred to exist around nearby stars by analyzing the wobbly patterns of starlight. But the planets themselves could not be seen. Suddenly, our solar system was not unique anymore. Astronomers got giddy over the inescapable conclusion that probably every star had planets. It became impossible not to ask the poignant question, is the Earth unique, or are there other Earths? What's the big deal about finding Earth-like planets anyways? Well, considering all the financial resources the developed countries are spending on finding Earth-like planets, it can be said without a doubt that it's definitely a big deal. Including the launched James Webb Telescope, which cost $10 billion, the Kepler Space Telescope, which cost $550 million, and the TESS satellite, which cost $200 million. The investment in finding Earth-like planets is certainly eyebrow-raising. Now, if you keep in mind that these costs are just for the hardware, and to get a sketch of the full magnitude of the search, you must also include the salaries of a team of data miners, PhD analysts, and postgrads all across the globe in universities, national space agencies, and private institutions. We will conclude that finding another Earth is truly an immense undertaking. Now, suppose we find one. Then Earth is not alone anymore. It's not that we can actually go to any of these planets anytime soon. Interstellar travel requires some breakthroughs in physics and technology, and, well, we aren't there yet. But knowing that there are planets out there in the Milky Way that are like Earth in all the essential respects, like liquid water, oxygen, and habitability, will make space less foreboding, more welcoming, more exciting to study and explore. It may also give us some more pride in our home planet and make us all better Earthlings. The triple mission looking for other Earths, the Kepler Telescope, the TESS satellite, and the James Webb Telescope use distinct approaches to find exoplanets. And the synonym TESS tells us what that method is. The T stands for transiting, and that's the key to the whole exoplanet search. E stands for, you guessed it, exoplanets, the target of the excellent investigation of another Earth. S stands for survey, because TESS looks at hundreds of thousands of nearby stars. And S stands for satellite, because TESS is orbiting Earth, unlike the James Webb Space Telescope, which will orbit the Sun. When a planet passes in front of a star, that is called a transit. The planet will block some of the light coming from the star. This decrease or dimming of the star can be measured. The dimming of starlight tells lots of things about the planet. By knowing how bright the star is and how much the star's light was dimmed by a transition in front of the star, we can tell how giant the planet is or how close it is, but we won't know which. Is it big or is it close? Until the planet's orbit is also timed. It means our TESS satellite must take long-duration videos of the stars. Ooh, video of the stars. Hollywood should like that. The TESS satellite doesn't have a telescope. It uses 4 CCD cameras to stream live long-duration videos of as many stars as possible, hundreds of thousands of stars. Why so many? Well, because for a transit of a planet to be observed, it must pass directly between the TESS satellite's cameras and the star. If the planet is not on the exact line-of-sight angle between the star and TESS's cameras, it cannot be seen because it will not cut off any starlights. Planetary transits are rare. For example, Venus passes across Earth's view of the Sun only every couple hundred years, Yet, TESS's cameras are seeing many planetary transits among the hundreds of thousands of stars it takes streaming long-duration videos of, and you know what that means. It means there must be hundreds or thousands of times more planets than are observed by the transiting method. It is, therefore, an inescapable conclusion that every star has planets. Planets are everywhere. And now, the James Webb Space Telescope, with its giant 21-foot, 4-inch wide mirror, is entering the search. It is a technological marvel, a wonder of the modern world, a miracle of advanced engineering. Anticipation is reaching a fever pitch. But with the heightened anticipation comes an almost equal amount of trepidation. And some things can still go wrong before the James Webb Space Telescope returns its first pictures. After the Hubble Space Telescope, for example, was launched in 1990, a repair mission had to be launched in 1993. The mirror on the Hubble was not very well inspected, and its pictures were very blurry. Astronauts had to go up and execute a spectacular spacewalk to fix the mirror. After the fix, the pictures Hubble sent back were more precise than it was ever designed for. This is how an improved model appeared. That cannot happen with the James Webb Telescope. The Hubble orbits the Earth and is accessible to astronauts. The James Webb Space Telescope orbits the Sun and is well beyond the Moon, out of the reach of astronauts, because there is no spacecraft equipped to carry him there. It cannot be manually fixed if something goes wrong. Adding to the challenges, the James Webb Space Telescope has only one onboard camera to inspect any damage it may suffer or mechanical malfunctions that might develop in the harsh environment of interplanetary space. Any remote fixes will need to be done blind from Earth. The James Webb Space Telescope is now fully deployed. The 18 mirror segments will need to be aligned to produce a single image. This critically important process will take several months to complete once the telescope is fully deployed. 70 of the first 286 observation assignments of the telescope target exoplanets. Using data from previous exoplanet searches, it will not have to waste time searching for exoplanets. Their locations and orbits are already known. The James Webb Telescope will go right after them. The James Webb Space Telescope is not an optical telescope in the same sense as the Hubble Space Telescope or any ordinary telescope that sees visible light. It sees infrared light. The pictures of planets are expected to be bright dots, somewhat fuzzy if they have atmospheres. The spectra of the planets will yield the most information about the exoplanet. Any gases around an exoplanet will absorb some starlight as the starlight passes through the planet's atmospheres. Suppose there is methane in the planet's atmosphere, oxygen, or carbon dioxide, the gases that most indicate life. In that case, the James Webb Telescope will be able to pick them up by spectroscopic analysis. An entire portrait of the exoplanet can be formed from the infrared information, its temperature ranges, atmospheric content, the likelihood of liquid water, and even the probability of life. And that's a big deal. The James Webb Space Telescope has other missions to perform too. It's assigned to examine star formation and planet formation in nebula in the Milky Way. Understanding how solar systems form is part of the search for another Earth. By detecting infrared light, the James Webb Space Telescope will peer to the farthest away galaxies whose visible light gets blocked by dust and gas. These distant galaxies were formed shortly after the Big Bang. Galaxy formation is an essential mission for the James Webb Telescope. These most distant galaxies are accelerating away so fast that the light they emit is stretched below the frequency of the visible spectrum, into the infrared. The Great Telescope can see these previously invisible galaxies. We hope to learn about the mysterious dark energy that is causing the universe to expand at an ever-increasing velocity. Hope is high that the James Webb Space Telescope will significantly expand our knowledge of this amazing universe we all live in.
One day, NASA will build a spaceship that can take us anywhere in the universe. Probably. And when this happens, we'll be able to find a new, beautiful home. Scientists even know what exactly they're looking for. We want a planet about twice the size of Earth with an average temperature of 77 degrees Fahrenheit, with a pretty dense atmosphere. Bigger planet means more room for water and potential homes. And a dense atmosphere means more protection from nasty space stuff, as well as more lush plants and cool animals. Thanks to the James Webb Space Telescope, we can now study exoplanets better from a distance. Of course, sending astronauts there would be much better, but oh well. Discovering new planets isn't easy though. It's like trying to find a tiny firefly in a pitch-black forest. Scientists had to come up with a clever method to find very distant planets. It's called the transit method. Here's how it works. Scientists capture a series of snapshots of a distant star at different points in time. Then, they scrutinize these images. They try to find any mysterious dark spots passing in front of the star. If they find one, it could very well be a planet. These snapshots hold the keys to uncovering vital information about these distant worlds. Not only do they tell us that there's a planet there, but also reveal its size, radius, and how close it is to its parent star. And most excitingly, they hint at whether it could ever become a new home for us. And now their research is finally bearing fruit. Recently, we've stumbled upon a tiny world nestled in the Cygnus constellation. It's called Kepler 22b. At first glance, it might not seem like a big deal, but this discovery has some pretty huge implications. This planet is located right in the Goldilocks zone. The Goldilocks zone, also known as the habitable zone, is a sweet area around a star where the conditions are just right for a planet to have liquid water on its surface. It's not too hot, so it doesn't evaporate, and it's not too cold, so it doesn't freeze. Hence the name from the famous story of Goldilocks and the Three Bears. So there might be water on Kepler 22b, and where there's water, there's a chance for life. And it's not just about life. Having a planet covered in oceans can be a game changer for climate stability, all because vast water bodies act like nature's thermostats. When the sun beats down on the hot parts, the water soaks up some of that heat and spreads it around like a blanket. The scorching regions cool down and the icy ones warm up and thaw out. Back in the bad old days of our Earth, the moon played a crucial role in helping water puddles spread across our planet. This is what helped our world transform from a fiery nightmare into the vibrant, life-packed orb we call home. Kepler 22b has about the same year length as our Earth. And if we're right about the whole ocean thing, scientists think its average temperature could be around a cozy 12 degrees Fahrenheit. But if this world also sports an Earth-like atmosphere, temperatures might soar up to a toasty 72 degrees. This world isn't too far away from us, only 635 light-years, which is about 3 quadrillion miles. Yeah, that's pretty close in space terms. Its sun is a yellow dwarf star, just like our sun, although there's a subtle difference. It's about 20% dimmer, so you won't see this star in the night sky even if you squint your eyes really hard. This star also happens to be quite chilly. Its temperatures are hovering around a frigid 10,000 degrees Fahrenheit, making it the Arctic of the starry skies. Luckily, Kepler 22b snuggles up to its star a bit more closely than we do to the sun. If it was in our solar system, it would find its place somewhere in between our familiar Earth and Venus. So the brightness and the temperature on this planet would be almost the same as on Earth. There are a couple of catches though. For example, this world might be quite a gymnast. It could be twirling around its star in a totally different way than Earth does. It might be tilted, like Uranus. If that's the case, the temperatures of the planet could be quite weird. You'll experience bone-chilling winters, followed by scorching hot summers. So let's hope this theory isn't true. If Kepler 22b has a normal tilt, its climate would be pretty similar to what we enjoy here on Earth. The next problem is gravity. Kepler 22b is about 2.4 Earth's size, which means the gravity there would be stronger. You'd feel noticeably heavier on this planet. It would be just like doing your everyday activities on Earth, but everything would require more effort due to the stronger gravitational pull. Simple things like climbing stairs or even just breathing would require much more energy. So it's time to build some muscles. People would have to adapt to the new conditions by having denser bones and more robust cardiovascular systems just to move around comfortably. Unfortunately, that means doing sports would be much harder too. But hey, at least people might need to consume more calories to sustain their activities, so even though you'd have to exercise more, you'll also be able to eat more delicious food. Buildings on Kepler 22b would likely be square and robust to withstand the stronger gravity, which would kinda be problematic because taller structures are super challenging and expensive to build. But the most important question is, what kind of planet is that at all? Yeah, it's the big question mark. Scientists aren't even sure that Kepler 22b is Earth-like. It could be a gas giant, or even a water world. A water world is a planet with a vast ocean covering its surface, and it's not just some knee-level deep water. It'll be insanely huge, thousands of miles deep and more, with no visible surface or any plants around for a long time. In that case, we could dream of building underwater cities. We could filter the water for sustenance and perhaps evolve into amphibious beings. Would that be a step backward or a leap forward in our evolution? Some scientists also lean towards the idea that Kepler 22b might be a mini Neptune. This is a legit planetary category, by the way, but that theory is still unproven. But let's say, for our sake, it's a rocky planet. Even then, we're in the dark about its atmosphere. Does it even have one? What if it's like Venus, toxic enough to make your ex look like a bouquet of roses? In that case, we'd have to dig deep into the planet's depths for survival, figure out a heat source, and hope for the best. While there's a lot we don't know, let's keep our fingers crossed and assume the planet is Earth-like. In that case, what would Kepler 22 look like? Well, because of stronger gravity, the planet's landscape might be full of rugged mountains, deep valleys, and powerful rivers. If there's life on this planet, it's probably quite small? Unusual plant and animal life should have adapted to the higher gravity. Trees might be shorter and sturdier. They'd struggle to break free from the soil. Animals might be pretty small too. They would also have strong, muscular legs for support. Perhaps these creatures would have numerous legs, making movement possible. They'd need to be small in stature, but gargantuan in strength. Muscular giant spiders sound not so bad, right? As for our beloved pets, they'd have to become little muscle-bound spheres just to survive. Also, the landscapes would feel very spacious because of the planet's sizes. A 3-day flight in a plane sounds like quite the adventure. There are many possibilities with Kepler 22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer the planet. That would be awkward if it turns out to be a gas planet or something like that.
2022 and 2023 have been landmark years for discovering new, fascinating worlds. Last year, NASA surpassed 5,000 confirmed exoplanets. The list is incredibly diverse. It includes rocky super-Earths, gas giants like Jupiter, ice giants like Neptune, and so on. And this is just the beginning. There might be more than 1 trillion exoplanets in our galaxy alone. But the most important question is, how many of them are habitable, for us? Are there any planets on this list that could have life on them? Or that could be a future home for us? Of course there are. And in 2022-2023, we found as many as 5 of them. So buckle up and hang on for a wild ride beyond our solar system. The first planet on our list is Wolf 1069b, a boring and stodgy designation. So I'll simply nickname it Wolfie, because hey, who's going to stop me, NASA? A new study conducted by 50 starry-eyed astronomers confirmed something awesome. This exoplanet, Wolfie, which is located just 31 light-years away from us, could potentially be a rocky world. In other words, theoretically, it's a habitable planet. The team behind this discovery used a technique called radial velocity to detect the exoplanet. This is a way scientists study the movements of stars and planets. It's as if when you're playing catch with a friend, as they throw the ball to you, you can see it coming closer and closer. It's kind of like radial velocity. When a planet is moving towards us, it makes the star it orbits appear to be coming closer to us. When the planet is moving away from us, it also makes the star look more distant. Scientists can use this information to figure out what the planet is doing and how big it is, and that's how they found Wolfie. This exoplanet is estimated to be the Earth's size and about 1 1/3 times the mass of our planet. It's orbiting a red dwarf star who I'll call Wolfie's mama. But here's the real kicker. Wolfie orbits within its star's habitable zone, which means it's a prime candidate for liquid water to exist on its surface. That's like hitting the exoplanetary jackpot. Ooh, wish I had a ticket. The study estimates that if Wolfie does have an Earth-like atmosphere, temperatures could rise as high as 55 degrees Fahrenheit, which would mean liquid water could pool on the planet's day side. But here's the catch. The exoplanet is tidally locked to its star, meaning that the same side always faces the star. Just imagine, one side of the planet is always basked in the warmth of its star, while the other is in eternal darkness. Like middle school. Just kidding. The team behind the discovery believes it's a prime candidate for further studies, but we'll probably have to wait another 10 years for answers. Until then, we'll just have to keep searching the skies with our telescopes and crossed fingers. Our next planet is TOI 700e. What's a good nickname? NASA has just discovered a new planet that's set to take the galaxies by storm, or shall we say by orbit. I'll nickname it Toys Were Us. It's almost the size of Earth, most likely has liquid water on its surface, and it's only 100 light-years away. We're not talking about a road trip, of course, but this is close enough in the grand scheme of things. Toys Were Us is the 4th planet in its system, and it's got a bit of a short orbit, just 28 days to circle its star. Well, at least you would have a birthday every month. Hooray! This time, the discovery was made using the transit method. Planets themselves are incredibly small and hard to detect, but when a planet is in front of its star, it blocks some of the light coming from it, making it look a little bit dimmer. As soon as the planet moves away, the star gets brighter again. So, to find the planet, scientists watch very carefully to see if the star's brightness changes. If it does, that means there's probably a planet playing hide-and-seek with us. And that's how they discovered Toys Were Us. The TESS mission discovered it. It discovered 66 new exoplanets and 2,100 more candidates waiting to be confirmed. TESS has been very busy creating imaging for 75% of the sky. Talk about efficiency. Toys Were Us is located in the optimistic habitable zone, between planets C and D, but it may be tidally locked, just like Wolfie, so we might have to settle for a one-sided water world. The discovery of Toys Were Us is a promising prospect for future follow-up observations, and it demonstrates the potential for TESS to find even smaller exoplanets in the future. Who knows? It may find a new home for humanity among the stars one day, or at least a new vacation spot. Next, we have twins GJ1002b and GJ1002c. The galaxy just got a little bit closer to us with the discovery of 2 exoplanets, which I'll nickname Hansel and Gretel, that are just a stone's throw away from our solar system. That's right, these 2 Earth-like planets are located less than 16 light-years away, which is just a hop, skip, and a jump in space terms. For comparison, Proxima Centauri b is the closest Earth-mass exoplanet at 4.2 light-years away. So, these 2 new neighbors are among the closest to us. They both orbit a red dwarf star with barely 1/8 the mass of the Sun. It's quite cool and faint, but that's okay, since both planets are very close to it. Hansel takes 10 days to orbit its star, while Gretel takes just over 21 days. Even more birthdays, I guess. The discovery was made by an international scientific team and was no small feat. The team had to work together with 2 instruments, espresso and Carmini's. The result? A cafe latte. Nah. What they got were measurements so accurate, you could practically count the number of craters on the planet's surfaces. The big deal is, the planets are located in the habitable zone of their star and are just the right size, making them excellent candidates for future atmospheric studies. The lead author says, "Nature seems bent on showing us that Earth-like planets are very common. With these two, we now know 7 in planetary systems quite near to the Sun. Who knew our neighbors could be so friendly? In conclusion, the discovery of Hansel and Gretel is a giant leap for humankind. So let's all raise a glass of H2O, or whatever they drink on exoplanets, and celebrate it. The last planet on our list is LP 890-9c, which I'll call Bob. This super-Earth, located about 98 light-years away, is roughly 40% larger than our home planet. Moreover, it has a twin, which I'll nickname Ray, which is up to 75% larger than Earth. More space is always good, right? The two planets orbit around the red dwarf star. Unfortunately, Ray is quite hot to the touch, with an estimated temperature of 253 degrees Fahrenheit, so don't touch. Its sibling, Bob, is located in the habitable zone of its star, making it a prime candidate for the potential of life. But let's remember that the actual temperature of the planets depends on their atmospheres. It's possible that Bob, being the outermost planet, has a runaway greenhouse effect, making it more like Venus than Earth. So it might be too hot to be habitable at all. But let's not lose hope yet. The James Webb Space Telescope, launched in December 2021, is on the case. With its cutting-edge technology and powerful instruments, including spectrographs, it can peer into the atmospheres of exoplanets and reveal which ones might be habitable. So let's see what it discovers. This planet has been listed as the second most favorable habitable zone terrestrial planet. Now it's on the list with 7 other Earth-like planets, all about 40 light-years away from us. Maybe they'll become our new homes in the future. Maybe we should fix the home we have. But until then, enjoy this moment and celebrate all these new discoveries. Who knows how many more planets we'll find in the future, considering how much technology develops each year? Thousands? Millions? Meanwhile, Bob and Ray, Hansel and Gretel, Toys Were Us, Wolfie and her mama will all be out there waiting for us. You're gazing up at the night sky. Wow! For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy. So if they were to point their telescopes at our Sun, sooner or later they would see a small dot that passes between our home star and the observer. This is called a transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomenon right at home with a telescope. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun, and now you see it as a small dot. Mercury transit process can last about 5 hours, and this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13th, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun, but because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the Sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit between the Sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the Sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700-plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot. And they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So, while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light-years from our home. Near the Ross 128 star, a red dwarf in the constellation Virgo. There's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the Sun on a regular basis for 2,000 years. But about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system. And 4 of them are in the habitable zone of the star. But they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope. And we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the Sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option how to deliver a message to a distant planet is to literally send a mail delivery there. It could be a space probe. And we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disk contains greetings in 55 Earth languages, a lot of music from different parts of our planet. Different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. These are pictures of people and earthly landscapes. In these pictures, there's information about the Sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the Sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the Sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Now suppose we made contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine we still got a return signal. It would be the slowest chat in history, because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space. So we have to take the first step. Although Proxima Centauri is the closest star to our solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light-years wide. So the journey from edge to edge would take 100 millennia. So, we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great and many more greats of the first crew will be able to see another star system from the spaceship portal. Hey, can you move your head? I'm trying to see out the window. While we may think of ourselves as advanced after catching a glimpse of the 8 planets of our solar system and their 200 moons, we really have little idea of what's out there. So much so that there's speculation that there might be one more planet in our solar system. Scientists call it Planet X or Planet 9. This undiscovered world could be hidden way out past Neptune. Asteroids and dwarf planets in this area have weirdly unexplained altered orbits, and Planet X may be the reason. Tales of this mysterious planet began over 100 years ago with a man called Percival Lowell. Lowell had a great love of space, and aside from having an impressive mustache, he was also super rich. Ooh, that lucky guy. He used his riches to build an observatory in Arizona. He then dedicated it to study the odd motions of Uranus and Neptune. Their gravitational pulls are slower than those of all the other planets in our solar system, almost as if there is a giant hidden object pulling them off course. In 1906, Lowell theorized that there could be another planet out beyond Neptune. It probably caused those strange cosmic happenings. The man called this potential space body Planet X. In 1930, Pluto was discovered by Clyde Tombaugh at Lowell's very own observatory. It finally looked like people had an explanation for the weird orbital patterns. Lowell's team was on cloud 9 after the discovery, but their celebrations were short-lived. Soon, they found out that Pluto is way too small to be having that much of an effect on the surrounding planets. And it was also too far away from them, so it was back to the drawing board. Planet X, if it exists, is 10 times the size of Earth and 4 times its radius. It would take at least 10,000 years for the planet to orbit the Sun, and it would sit over 200 times further out than our home planet. That's 600 astronomical units from the center of the solar system. FYI, an astronomical unit equals the distance between the Earth and the Sun. But while that sounds super far away, it's actually not. The distance between space bodies is usually measured in light years, and an astronomical unit is a much smaller unit of measurement. For context, the most distant thing detected from Earth is the galaxy GNZ11. Cute name, huh? It sits a staggering 32 billion light-years away. Even so, our telescopes can still spot it, and just 1 light-year is the same as 63,241 astronomical units. Woo! So, if our tech can detect a galaxy that's so far away, how have we not been able to uncover Planet X? Well, it's probably down to the fact that it might not even exist. The theory of Planet X was pretty much debunked back in 1989. It was discovered that the mysterious gravitational pulls of Neptune had been a red herring all along. Scientists had massively misjudged just how big Neptune actually was. Voyager 2 visited the planet and discovered its actual size. This new info explained the odd gravitational pulls, meaning they weren't being caused by the so-called Planet X. But that's not where our investigation ends, as the hypothetical 9th planet once again popped up around 10 years ago. While the evidence behind Lowell's theory was wrong, his belief in Planet X may not have been. In 2015, astronomers Michael Brown and Konstantin Batygin discovered that there were, in fact, unexplained gravitational forces at play past Neptune. There are satellites that orbit planets perpendicularly, which doesn't happen anywhere else in our solar system. There's also clusters of asteroids that move in very specific ways, so specific that it's basically impossible that it could be random. Even weirder, there are satellites that travel in completely opposite direction to the Sun, unlike most other things in the solar system. A planetoid called Sedna also appears to be being pulled towards something, along with 6 others, all going in the same direction. And Brown and Batygin aren't just any other stargazers. They're both well-respected scientists at the top of their game. Konstantin Batygin has been named in Forbes as one of 30 scientists who are changing the world. And Mike Brown was the man who rebranded Pluto as a dwarf planet. This means that when these guys say something, it's usually pretty legit, and you should probably listen. But the only way we can really prove Planet X exists is to actually find it, and this has turned out to be pretty difficult. To locate the planet, we'd need to use a method called transit photometry. This is basically where we monitor a whole bunch of stars for a long time and look out for any dips in the light they give off. These dips would likely be caused by a planet getting in the way, and ta-da! The existence of Planet X could be proved. But for this method to work, Earth, the new planet, and the Sun all have to be perfectly aligned. These circumstances are pretty rare, and if these conditions don't exist, the dip in light won't happen. Plus, this method would only really work with planets that are closer to the Sun than our Earth. That's Venus and Mercury. For anything past Earth, this technique is pretty much useless. Another technique we could use is to find the potential planet through a good old-fashioned telescope. But as you can imagine, that's insanely tricky. The furthest object that we've found in our solar system is a planetoid appropriately named Far, Far Out. But that's only 140 AU away from the Sun. That's only like a quarter of the way to Planet X. We can only see an object because of its brightness. The Sun is very visible to us because it emits huge amounts of light. And we can see the Moon because it reflects the Sun's light. Technically, the Moon has no right to appear brighter than everything else in the night sky. It only seems brighter because we're closer to it. The farther away an object is, the less bright it appears to us. The major issue with seeing the theoretical Planet X is that all objects in our solar system get their light from the Sun. They reflect sunlight, and that's why we can see them. Given how far away from the Sun Planet X might be, it makes it nearly impossible to see. And because of its really dim light, to view it, we would require perfect weather conditions as well as an extremely strong telescope. But Brown and Batygin have found the perfect one. The Subaru Telescope is located at the top of a dormant volcano in Hawaii. It's huge and is capable of capturing even the weakest light from distant space objects. The issue that we need to figure out is where to point it. Without knowing where Planet X actually is, this basically turns things into a giant guessing game. There are also only around 3 nights every year when the conditions are clear enough to see the hypothetical Planet X. It's difficult, but not impossible. And still, most astronomers have called it a day and agreed that Planet X doesn't exist, stating that it's just a common myth. The most widespread explanation for the weird gravitational pulls is that there's a tiny black hole in our solar system. It's pulling the planets toward us. But don't worry, they say it's not big enough to actually munch on a planet. So Earth is all good, for now. The issue with the black hole theory is that, once again, it's almost impossible for us to track the thing down. While its mass could be as great as that of Planet X, the hole itself would be squished down to the size of an orange. Telescopes wouldn't be of any use. To find it, people would have to look for the gamma rays sent off by objects as they fall into the black hole. Another way we could find it is to release hundreds of tiny spacecraft. They would pass close enough to the hypothetical hole, and when they got pulled toward it, we could probably detect it. But don't count out Brown and Badigeon's theory. It's still being documented by NASA. And until we find unmistakable evidence to prove any theories, Planet X might still be out there.
Have you ever wondered what it would be like if every planet in our solar system was the size of Earth? Well, it's time to dive into this mind-boggling scenario. Let's imagine what each planet would look like if they were as big as our beloved blue planet. Would the barren red landscape of Mars suddenly become a lush green oasis? Would the massive swirling gas giant Jupiter just disappear? And how would it affect our solar system as a whole? Are we all doomed? Buckle up and let's find out. The first planet on our list is Mercury, the smallest planet in our solar system. But now, forget about the moon-like Mercury. Instead, picture yourself on the surface of a super dynamic incandescent inferno. There are a lot of craters and active volcanoes around you, and right in front of you is a huge, blinding bright sun. What a nightmare! But let's break these changes down. Well, along with the size of Mercury, both its mass and gravity would increase. In that case, it's possible that Mercury would have more atmosphere. Temperatures on Mercury are extreme, not only because it's very close to the sun, but also because of its very thin atmosphere. So during the day, the temperatures there reach 800 degrees Fahrenheit. And at night, it becomes terrifyingly cold, down to negative 290 degrees Fahrenheit. But now, when the gravity is stronger, Mercury could have a denser atmosphere, so the heat would be better distributed across the planet. And the atmosphere isn't the only thing that could make it hotter. If Mercury became bigger, it would likely experience increased internal heating due to gravitational compression. And hypothetically, its tectonic activity could increase. In other words, more interesting landscape, more mountains, and more scary active volcanoes. Congratulations, you've turned Mercury into Venus 2.0. For us, all these changes wouldn't be very pleasant. Now, it would become much harder to send our spacecraft there, so it's better for Mercury to stay as it is, small, calm, and boring. Basically, the complete opposite of our next planet, Venus. So what would happen to Venus if it was Earth-sized? Actually, nothing. It wouldn't change at all because Venus is already almost the size of Earth. It's even called the Earth's twin, although twin is a big word, of course. In reality, we couldn't be more different. Venus is often called the morning star because it's so bright and visible in the sky. But don't let its beauty fool you. This planet is one of the most inhospitable places in our solar system. Its surface is hotter than a freshly baked pizza, around 900 degrees Fahrenheit. And it's covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. So, unfortunately, you won't be planning any trips there anytime soon. So let's move on to a planet that, unlike Venus, could potentially become a new home for us: Mars. Picture yourself standing on Mars's surface, watching the blue sunset and breathing in a refreshing breeze of air. Yes, you read that right, air. Moreover, you could be surrounded by plants, animals, and basically feel like you're on Earth. But how is that possible? Bigger Mars would have a stronger magnetic field and gravity. This would lead to a richer and denser atmosphere. It would likely have a wider range of gases, including oxygen. Wouldn't that be cool? Also, a denser atmosphere could distribute heat across the planet, so Mars would become much warmer and cozier. And here comes the most important change: liquid water. Mars actually has some frozen water at its poles and in subsurface reservoirs. But with a stronger gravitational pull, it could potentially stabilize liquid water on its surface. Hooray! However, it's not all fun and games. New Mars would also have a volcanic personality. It's already geologically active, but now its internal heat and pressure would skyrocket. That means more frequent and more crazy volcanic eruptions. Imagine how exciting it would be to witness such eruptions on another planet, if you manage to escape the consequences. In general, the planet could become greener and lusher, but not safer, although it would still be great to see it. But it's time to move on to the giants of our solar system. And if we're enlarging the planets before, now it's time to squeeze them really, really hard. If Jupiter became 11 times smaller, oh boy, what a disaster that would be. The first thing we'd notice is a change in gravity. And I say we'd notice because now we'd have no choice but to move somewhere. Jupiter experiences from 30 to 100 collisions with large asteroids per year. No big deal, all because of its strongest gravity, which attracts them all and protects us. But now our big protective brother has turned into a small baby. Say hi to a bunch of asteroids. Oh, and say bye-bye to Jupiter. This planet is known for its thick, swirling atmosphere. But with a weaker gravitational pull, Jupiter would probably have a hard time holding on to it. So over time, it would slowly escape into space, leaving behind a thin atmosphere composed mainly of nitrogen and oxygen. We'll also have to bid farewell to the iconic appearance of another giant, Saturn. The most noticeable difference would be the disappearance of its famous rings. Made up of small particles of ice and rock, the rings are a unique feature of Saturn. But with Earth's gravity, they would either fall onto the planet or scatter into space. Bummer. Saturn is also a gas giant, just like Jupiter. Its atmosphere is made up of mostly hydrogen and helium. But if it were Earth-sized, its gases would be compressed due to the increased gravity. This would make it much denser. That means Saturn's overall size and shape would change. Theoretically, if we squeeze Saturn hard, it could potentially become a brown dwarf. It's a type of failed star that lacks the mass to sustain nuclear fusion, but emits heat and light. So, Saturn could stop being a planet altogether. The weather on it would probably have changed too. All its crazy storms, such as the famous hexagonal storm at its North Pole, would have become weaker and calmer. The next giant is Uranus. Let's try to compress this poor fella. First off, the surface gravity on Uranus would be much weaker than it is now. Its atmosphere might also change. If Uranus was smaller, it could have a thinner atmosphere and different gases altogether. This planet is pretty chilly, with an average temperature of -353 degrees Fahrenheit. Ugh. But if it was the size of Earth, it might actually warm up a bit due to its reduced volume to surface area ratio. Don't get too excited though, it would still be way colder than the coldest spots on Earth. As you can see, gas giants don't easily go through all this shrinking, except perhaps one of them. Surprisingly, small Neptune would become much friendlier. For starters, it would probably be a rocky planet with a tiny atmosphere. That means no more gas giant, but instead, a planet that's easier for humans and critters alike to live and move around on. Speaking of movement, because of the smaller size, the gravity on this new Neptune would be almost the same as Earth's. making it a heck of a lot easier to walk and jump around. No more floating away into space. Now, the atmosphere of the original Neptune is so thick you could barely see your hand in front of your face. And the surface pressure is about 100 times that of Earth's atmosphere. But our new Neptune would be much different, with a much thinner and less dense atmosphere. It would still have some methane, water, and ammonia in it, but nowhere near as much as before. Finally, the temperature. The current Neptune is freezing, with an average temperature of about negative 370 degrees Fahrenheit. But if it was the same size as Earth, it would likely be much warmer, just like Uranus. Ah, that's more like it. What a planet that would be. That's it for the changes in the planets. But what would happen to the entire solar system if we made all the planets so small? It's hard to predict, but it's clear that their gravity and orbits could change a lot. It's unlikely that any of them would have flown into outer space, or crashed into each other, or something like that. But many of their orbits would probably become quite unstable, and the number of collisions with asteroids would have increased significantly. Of course, all this is purely speculation. It's not like we can actually test all this. But it's still a pretty interesting thought experiment, and it makes you appreciate just how unique and special our solar system really is.
We're far from that, but it's still nice to imagine. At the moment, our civilization is in the stage scientists named an immature technosphere. That means we're still too focused on using technology that doesn't always do good for our planet. We don't have a planetary intelligence or a collective understanding of what needs to be done to do better for our planet. Instead, we're all just doing our own thing. I mean, we're not at the worst stage. researchers have come up with 4 stages of Earth's past and future to explain how planetary intelligence could impact the long-term future of humanity. The first stage is what we call the immature biosphere. It's when life first started on Earth, billions of years ago. Only microbes were there on the bare land without any vegetation. There wasn't any global feedback, which means these microbes couldn't yet affect Earth, its atmosphere, or other systems in any way. The second stage is the mature biosphere, which was 2.5 billion to 540 million years ago, when stable continents formed and the biosphere started to have a strong influence on the Earth. The third stage, known as immature technosphere, is where we are now, with interlinked systems of communication, technology, transportation, electricity, and computers that draw resources from Earth's systems and affect the biosphere. The fourth stage, also known as the mature technosphere, is where Earth should aim to be in the future. It means technology will benefit the entire planet. We'll use sustainable forms of energy, like solar power. Planetary intelligence is the sign of a mature planet, and researchers are trying to figure out how we can move towards it. So, things we do on an individual level do matter. The collective activity of life, like microbes or plants, can change a planet and make it more than just a lifeless rock floating in space. Through the biosphere, our home planet kind of figured out how to host life by itself billions of years ago, and it's still going. Now we need to figure out how to have a similar kind of self-maintaining system, but this time with the technosphere. It's hard to imagine planets could generally become sentient, like Pandora or some other imaginary conscious world out there. There are a few reasons for that. First, planets form based on how different materials like rocks, gases, and liquids gather around a new star. It's like you have a big family gathering, where everyone brings different ingredients to make a delicious dish. And just like how these ingredients won't suddenly turn into a living being, the materials that make up a planet won't just turn into self-aware creatures. On Earth, after billions of years of complex chemical reactions, some molecules started to replicate themselves and carry information. That's how life on our planet began. And Earth is the only such example we have. Here's the second reason. Imagine you have a big garden where you plant a lot of mushrooms or bacteria, hoping they'll become really smart and help you take care of the garden. But mushrooms and bacteria don't have brains like we do. It's not like they need it anyway. Having a big brain is really expensive for animals too. It takes a lot of energy to keep it running. So, animals only become as smart as they need to be to survive and thrive in their environment. Dogs and cats are pretty smart because they need to be able to avoid danger and find food. They don't need human kind of intelligence for things like building houses, creating art, or inventing new technologies. So, it would be hard to bring all living beings and plants to the same level of intelligence. The third reason why it would be difficult for a planet to become sentient is the main rule of the animal kingdom. Life is all about survival of the fittest. Every creature is competing for resources like water, food, and space. But not only do different species compete against each other, but individuals within the same species also fight. Just think of how fiddler crabs fight for territory on the beach, or how wolf packs fight over prey. Or me, when I see an empty spot on a crowded beach. This kind of competition is not a good base for global cooperation. There are a couple of exceptions to this rule. For example, ants. They may not be the brightest creatures on the planet, but when they come together in colonies, they can achieve amazing things, like gathering food that's way bigger than them, building nests, raising young, and even farming. In fact, they act like a superorganism called a hive mind, where every ant works together towards a common goal. Insects like bees and ants are very altruistic and work together to ensure their queen reproduces. If one large ant colony took over our whole planet, it could act as a single mind and work towards the colony's and planet's interests until they run out of resources. But in reality, it's hard to imagine any organism, even a superorganism, could reach such a level of self-awareness and consciousness. Number 5. How could we keep in contact? When it comes to communication, ants use pheromones and humans use nerves. Both of these methods work well for small organisms, but when it comes to a giant planet-sized entity, it would be hard to make such communication fast and efficient. So, communication within a planet-sized entity would be much slower than what we have in our homes, like our computers or smartphones. Oh well, we'll just continue dreaming about Pandora.
This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please.
One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto, valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The Sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the Sun. A protostar is a young star that's still gathering its mass, and that's exactly what the Sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the Sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the Sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the Sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler 62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the Sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the Sun takes 153 hours, because it's pretty far away from the Sun. After several hours without sleep, we get tired and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches, so it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home though. Once the sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home, not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the sun first grew too much, and then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice: sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board: malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick: orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, we could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe too, because of the trees. Then, we can melt Mars's polar ice caps and voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us.
Today, we're going to work our core, so get ready to sweat. Oops, sorry, wrong core. Hey, we've traveled far and wide, down to the Earth's inner core and up into outer space. But what if we could combine these adventures and find out what hides in the innards of other planets and moons in the solar system? With the help of this interstellar hyperdrill, we can achieve that, at least in part. Coordinates are in, all systems ready, and our first destination is the Moon. Our moon, in fact. We land on its gray and desolate surface under the black sky. No blue here because there's very little atmosphere to disperse the light. The drill starts working, and we first go through the outer layer of the moon, the crust, just like on Earth. We're on the sunny side, so the thickness of this layer is only 43 miles. But were we to land on the dark side, it would be more than twice as thick. The moon is a rocky body, so its crust is largely made of silicon, iron, aluminum, calcium, oxygen, and magnesium, with much smaller amounts of other elements. Further down, we find the mantle, and it's a long and tedious journey through. This layer is about 850 miles thick, It gets hotter as we go deeper, finding composite minerals, pyroxene and olivine. They're made of iron, silicon, oxygen, and magnesium in different proportions. Finally, we break through the hard layers and into the semi-molten outer core. Another journey of about 93 miles ahead through this scalding swamp. And we dive into the iron ocean of the liquid core shell. It's nearly 60 miles thick, and the molten metal threatens to evaporate us. But this drill was made to sustain an extremely heavy onslaught. And that's how we finally come to a sudden halt. In the deepest reaches of the moon, there's a solid iron core, which is 150 miles thick. We could drill through it, but it would be unnecessary. So we just set the flag here and skip to the next planet on our drilling list. And it's Mercury. It was hot deep inside the moon, but on the surface of the smallest planet in the system, it's even hotter. That's because it's so close to the sun, of course. Alright, let's drill. Mercury has a pretty thick outer shell, which is both crust and mantle, going about 250 miles deep. Not the most fascinating journey, it's not unlike the Earth in many respects. But then, the drill stops, ramming into a solid metal wall. It's Mercury's core, which has a diameter of over 2,500 miles. It takes up to 85% of the planet's overall diameter. No use trying to drill through this one. It's fully metal and extremely dense. Skipping to the next planet, and we're on Mars now. Oh look, it's sunset here, and the sun is making the sky hazy blue. But you know the drill. I mean, we're here to drill. So that's what we do. Mars's crust is quite thin compared to Earth's, just 6 to 30 miles deep. Its composition is much the same though: iron, aluminum, calcium, potassium, and magnesium. That's one of the reasons why humans are looking to colonize the red planet one day. It's very similar to our own. We're very quick to drill through the first layer, and the second one, the mantle, is now upon us. It's a hard and rocky layer about 1,100 miles thick. Thanks to its size, Mars isn't seismically active any longer. There's simply no magma boiling close underneath the surface of the planet, making it silent and docile. It's a long dig, but we finally come to a screeching halt, bumping into the core. A ball of iron, nickel, and sulfur with a diameter of 2,000 to 2,600 miles. This core is bigger than that of Mercury, but the planet itself is larger too, so it figures. Okay then, our next stop is even more interesting, because it's Jupiter. This gas giant has a mass twice that of all the other planets in the solar system combined. And we landed right in the middle of an ocean. The ocean, I dare say, it's the largest one in the whole system, and it's made of liquid hydrogen. The drill goes smoothly through the surface of the planet because there's no rock or hard metal here, only gas and liquid. But the shaking, yikes! The pressure on this planet is more than just huge, it's unimaginable. The drill is barely able to withstand it, and as it's going deeper, the pressure's becoming higher too. We've reached Jupiter's core, and it's nearly too much to bear. The temperature here is about 90,000 degrees Fahrenheit, and the core itself is not solid but liquid as well, kept together by the immense pressure from all sides. The drill starts to rattle. Bad sign. Let's get out of here before it breaks. Whew! No winds, no pressure, no heat. All around us is a vast icy wasteland, crisscrossed by ridges and reddish bands. It's Europa, one of Jupiter's most promising moons. As we drill through the ice, let me explain. Europa is one of the candidates to have extraterrestrial life in the solar system, and it can be found right beneath the icy shell through which we're now digging. It's only 10 to 15 miles thick, while down below is an enormous saltwater ocean, twice bigger than all of Earth's oceans combined. The deepest point on Earth is Challenger Deep, and it's a bit over 6 miles down. The ocean on Europa, on the other hand, can be up to 100 miles deep. Who knows what can be lurking in that deep, dark sea? Anyway, we travel fast through the water and finally reach the bottom of the ocean. The mantle starts here, and it's made of rock, just like on Earth. And not much deeper in, we find the metal core of the moon. Europa is a little smaller than Earth's moon, so it's no surprise we reach its center pretty fast. Okay, skip drive on. Let's go further. Oh, I'd rather we drill in as fast as we can. Just look around. It's blazing here. We're definitely on Io, another moon of Jupiter and the most volcanically active world in the solar system. Look, that volcano is twice the size of Everest, and it's erupting right now. Thankfully, we're under Io's surface already, but that's not to say we're safe. It's all molten down here too, mostly yellow and brownish hue, due to the huge amounts of sulfur. The stench must be horrible. Anyway, the most peculiar feature is that both inside and outside, everything's always on the move on Io. Jupiter and its other moons create tremendous tidal forces, making the surface of Io swell over 300 feet up and down. Like the largest tsunamis on Earth, only here it's not water but rock. The deeper we go, the calmer it gets though, until we're finally at the iron core. It's still hot here, but at least there's no shaking and swelling like above. Let's put up another flag and go to the next point. And that would be Saturn, the second largest planet of the solar system and the one best known for its spectacular rings. Not the only one to have them at all, mind you, but we'll get to it. Now, as you've surely noticed, our drill is simply falling down through the gaseous hydrogen and helium, making up most of the planet's surface and atmosphere. No need to work here, just wait and hope the immense pressure won't crush our drill to a hunk of junk. At last, the pressures become so enormous that we find ourselves in the liquid hydrogen, and here we start diving. Soon we'll reach the solid core of Saturn. Here we are. It's made of iron and nickel and is actually quite small compared to the rest of the planet. Well, the last destination awaits, so come on. And here we come, Neptune. The drill immediately deploys anchors because the winds here are extremely powerful. They reach speeds 5 times greater than the most devastating hurricanes on Earth. Neptune is covered in a pretty thin layer of hydrogen and helium, just like Saturn or Jupiter. But underneath, there's much more than that. It's hot, windy, and lonely here on the outskirts of the solar system. So let's dig already. Beneath the gases, there's suddenly a bubbling hot mass of water, methane, and ammonia. Phew! These substances are hot, despite Neptune being called an ice giant. The name comes from its core. Deep inside, where we're quickly headed right now, a small ball of rock and ice sits all alone. And despite the boiling temperatures above, the ice beneath is ever cold.
As soon as the Earth is cut in half, almost all living creatures will come to an end. An apocalypse will begin, which has not been shown in movies. The atmosphere is damaged, the magnetic field will change, and the planet's landscape completely alters. But the planet will be completely renewed, and life, like a phoenix, will be reborn from the ashes. A super powerful laser would be needed to separate the planet. Such a laser has to receive energy directly from the sun. The weapon goes into space on a rocket, thousands of miles above our world. Then, once the laser arrives at its destination, it opens wide to expose plates of solar panels. The laser absorbs and concentrates the sun's rays. Then a powerful energy beam with the diameter of several cities shoots into the middle of the planet. Oceans through which the beam passes boil and evaporate from the high temperature. These vapors turn into a vast thundercloud in the sky. A strong wind drives these clouds over the continents. Heavy rain falls, which floods not only cities, but entire countries. As the tectonic plates shift, tsunamis are created. Huge waves crash onto the shore. The Earth is split in two. And this is just the beginning. The structure of the Earth, or rather, each half of it, is changing. Strong earthquakes occur all over the world. The worst disasters happen near the fault line. Billions of tons of ground are smashed. Massive landslides drag entire cities below. Chunks of land, thousands of miles in size, shoot away from our planet. All living creatures on these pieces of land fly into outer space. Other broken pieces of the planet land on the half that is closest to them. Imagine a huge rock the size of a whole city falling from the sky, and there will be hundreds or thousands of such stones. Those who live far from the cut site have a chance to survive, but even there, earthquakes will destroy houses. the moon will also start to throw off pieces from itself. These pieces, like a meteor shower, will fall onto the Earth halves and create massive explosions. These explosions will create fires. The skies will be covered with ash, and until it settles, we won't be able to see the sun. Both parts of the planet are drifting away from each other. The red-hot heart of our Earth is right in the center between the two. This is the Earth's core, consisting of molten metals. Each half of the core exudes energy comparable to a star. Between the two parts of the planet, a layer of such hot space is created that nothing can survive there. Any item that falls into this space immediately turns into ashes. The mass of the core is much larger than the ground mass, so there's a higher level of gravity. The core sucks in everything that comes close. You can't travel from one part of the Earth to the other. The core's gravity attracts any shuttle. Each half of the Earth now lives on its own. Typically, the core inside our planet rotates and creates the Earth's magnetic field. This field is a shield that protects us from the sun and space. If the shield is damaged, solar and cosmic radiation passes through the atmosphere. Because the core is divided into two parts, the Earth's magnetic field becomes unstable. Power outages begin in both parts of the planet. Microwaves, TVs, kettles, traffic lights, computers, everything is broken. The screen of your laptop or phone starts turning on and off. The video may freeze and the battery runs out and charges in 1 second. Satellites stop working, which means there will be no more GPS. High-frequency radio waves used for communication stop working, which means you can't make calls and send texts. In fact, all power plants may sink underground or be flooded because of the earthquakes, so there might not be electricity at all. Some people are sensitive to solar storms and experience severe headaches. When the magnetic field is damaged, the surviving people and animals will suffer from severe migraines. Scientists will have to invent special helmets to protect people from the sun. For full protection, people will have to live in underground cities. Compass needles no longer point north. They just spin in different directions. The birds go mad. They don't know where to fly to wait out the winter because the south no longer exists for them. All animals stop migrating. In the sky, planes can't navigate. Plants and flowers can't grow naturally thanks to the increased radiation from the sun. Livestock are poorly fed. The quality of products deteriorates. There's famine. The main goal for people on each half of the planet is survival. In some places, closer to the fault, the Earth's atmosphere is completely damaged. The conditions there will be similar to those in space. There is no air or heat. Only in a spacesuit can you stay in this territory. Unfortunately, you won't be able to jump and fly because gravity still works. Besides, it's gravity that becomes the salvation of our planet. Both parts of the Earth won't fly away from each other because of the force of gravity. Instead, they will rotate and start to attract each other. In 100,000 years, both parts of the planet will reconnect once more, and the Earth will be completely renewed. Since the core is molten metal, it will return to a single heart, but it will take much longer to connect the solid rock of the halves. A scar forms along the entire fault. The scar will be overgrown with forests and flooded with oceans, but there will be strong earthquakes in some places near this scar. By this time, all living things have probably disappeared. On our planet, conditions are about the same as 4.5 billion years ago. Seas and oceans boil, lightning strikes everywhere, tectonic plates change their shape, and lava flows from volcanoes in a rapid stream. The Earth looks like a vast boiling pot, inside which life is gradually created. Because the Earth has decreased in size and the core hasn't changed much, the gravity will be different. On land, it will be more difficult for an ordinary person to walk. They will weigh much more. In such conditions, new, previously unknown life will be created. Today, the world's atmosphere and oceans are polluted. The population is increasing, and glaciers are melting. In the future, things could be much worse for our planet. In 1,000 years, when humanity has mastered space travel, we may decide to change our residence. We'll start looking for other Earth-like planets, and maybe we'll find something. However, nothing compares to our first home, and humanity decides to cure it. Perhaps we'll come up with the idea to divide the planet in half and live on one side. And after 100,000 years, we can come back to a new healthy home. What if you divide other planets? Since they don't have a magnetic field, they won't be as affected. For example, Venus and Mars have no seas, oceans, or lakes. Some scientists think they're entirely dried up because the magnetic field has disappeared there. This led to the complete destruction of the atmospheres of these planets. The solar wind blew across their surface with such force that it dried up all the liquid. The Earth's atmosphere reflects this wind, so thankfully, we're safe. There would be no significant cataclysms on other planets, except for earthquakes. Like Earth, the two parts of each world would simply rotate until they reconnect once more.
Well, looky here. You're about to figure out what lies under the surface of each planet in the solar system. Get into your spaceship, equipped with the largest drill you can only imagine, and off you go. You start with Mercury. It's the closest planet to the Sun. At first sight, the place looks similar to our good old Moon. But after landing, you understand it's an illusion. All around your spaceship, there are craters left by meteorites. The planet's surface is littered with huge steep hills. Some of them are 2 miles high and stretch for hundreds of miles. You start drilling and immediately understand it's going to be tough. Mercury is the second densest planet in the solar system, topped only by Earth. The planet's outer shell is 250 miles of solid crust and rocky mantle. After getting through it, you see Mercury's metallic core. It takes up almost 85% of the planet's volume and contains more iron than any other planet we know about. You don't need to drill anymore, the outer core is liquid. But once you reach the solid inner core, you have to switch that drill on again. The next planet you're going to explore is Venus. It's the hottest planet in the solar system. The average temperatures there are high enough to melt lead. The pressure on the planet is 90 times greater than that on Earth. Your spacecraft is traveling through thick clouds of sulfuric acid. Venus's surface is reddish-brown and extremely dry. You land in the middle of a flat, smooth plain. Plains like this cover 2/3 of the planet's surface. Well, you get down to work. The drill starts moving through the crust. It consists mostly of basalt and is almost 12 miles wide. The next layer is a molten rocky mantle. After some time, you get the feeling it'll never end. No wonder, it's 1,200 miles thick. Finally, you arrive at the planet's metallic iron core. It's huge, twice wider than the mantle. See that blue sphere slightly to the left? It's Earth! How about you skip it for the moment and get back to it later? Right now, Mars sounds so much more exciting. Whew! The place is freezing cold. The temperature is minus 80 degrees Fahrenheit. The planet looks reddish, and as soon as you make your first step on its surface, it becomes clear why. The ground's covered with rusty-colored dust. Its fine particles are also floating in the air around you. In most places, that dust layer is 7 feet thick. You start drilling through the planet's thin crust. It's made up of volcanic basalt rock. Pretty soon, you reach the mantle. It's composed of oxygen, silicates, and other minerals, something like a soft, rocky toothpaste. The red planet's mantle is much thinner than Earth's. It's 1,100 miles thick at most. You feel that the drill begins to move a bit differently. Must be the core. It's made mostly of iron, nickel, and sulfur and is between 900 and 1,200 miles across. And unlike Earth's core, it doesn't move. Time to visit the largest planet of the solar system, Jupiter. Almost 1,300 Earths could fit into this huge thing. It's also alarmingly hot, about 43,000 degrees at the core. But you can't land on Jupiter because it doesn't have any solid surface. The planet is a gas giant, the key word here being gas. Your drill is also of no use, at least at first. While descending, you watch thick brown, yellow, red, and white clouds passing by. Thanks to them, the planet looks colorful and beautifully striped. You keep going deeper toward the center of the planet. Its atmosphere is made up of hydrogen and helium gas. Soon, you see the hydrogen become liquid under immense atmospheric pressure. And closer to the core, this liquid turns into a mixture of metallic hydrogen and helium. You reach something that looks like a core, but even with the help of your equipment, you can't figure out whether it's a molten ball of liquid or a solid rock 14 to 18 times the mass of Earth. Maybe, one day, astronomers will help you answer this question. The next planet turns out to be exceptionally windy, like me. The winds on Saturn travel at more than 1,100 miles per hour at the equator. From above, it looks as if the gas giant has a solid yellowish-brown surface. You get through several different layers of clouds, and suddenly, you realize you can't land your spacecraft here as well. Saturn is the least dense planet in the solar system. It has only 1/8 the average Earth's density. If you found a pool of water large enough to fit the ring planet, the gas giant would float. If you kept going down, you'd probably have found Saturn's core. It's likely to be rocky, with hydrogen and helium surrounding it. You're approaching the ice giant Uranus, which means there's going to be some surface to land on. Or not. The planet isn't solid. You fly through the upper atmosphere and sink into the liquid icy center. The ice, which makes up 80% of the planet's mass, is actually a hot, dense fluid. It consists of water, ammonia ice, and methane. This part of the planet is sometimes called a water-ammonia ocean. This ice surrounds a solid rocky core. That's where you can finally use your drill. The core's small, half the Earth's mass. Compared to other planets, it's also rather cool, a mere 9,000 degrees. You're reaching the farthest point of your journey, Neptune. It's 4 times the size of Earth, but 17 times as heavy. The bluish surface you see when coming closer is a layer of permanent clouds and swirling gas. Below this surface, there's a large mantle, liquid and red hot. The mantle is rich in methane, ammonia, and water, and equals 15 Earth's masses. At last, you have something to drill. The planet's core is solid. It consists mostly of iron and other metals. Keep drilling until you're at a depth of 4,500 miles. Astronomers are almost sure that's where you'll find a diamond layer. That's right, it rains diamond crystals there. Well, time to go back home. People have drilled pretty deep holes here, but they were never deep enough to even get through the crust. After the drills traveled 1/3 of the way, the temperature reached 360 degrees, and the equipment couldn't operate any longer. But your drill is much stronger than that. That's why you easily move through the crust. It takes up only 1% of Earth's volume and is broken into tectonic plates. They let heat escape from the Earth's interior. You reach the mantle. This layer is about 1,800 miles thick and makes nearly 84% of the planet's volume. It consists of silicate rocks rich in iron and magnesium. Well, you don't need to drill anymore. The 1,500-mile thick outer core is liquid. It consists of iron and nickel, but the pressure isn't high enough for it to be solid. You pass through the boundary between the outer and inner core. It's quite a challenge. The temperature there is 10,800 degrees, as hot as on the sun's surface, and the pressure is 3.3 million times the atmospheric pressure at sea level. The inner core is a solid ball made of iron and nickel. Its radius is 760 miles. It makes 20% of the Earth's radius and 80% of the Moon's. Scientists know what's going on under the crust of the planets that are millions and billions of miles away from us. And they don't even need to go there, drill through their surface and peek inside. They combine information about the planet's density, magnetic field, mountain ranges, heat, and seismic activity to make their smart assumptions. For example, Earth's magnetic field shields us and the atmosphere from solar flares and solar winds. Scientists believe that it exists thanks to a hot iron core inside the planet. It rotates and generates invisible protection, like an enormous scorching hot dynamo. And this magnetic field is way stronger than that on Mars. It probably means that something happened to the red planet's core. Maybe it cooled down and kinda switched off. Or maybe there wasn't any magnetic field to begin with. There are loads of active volcanoes on Earth's surface. That's how scientists can conclude there must be a relatively thin crust, and the mantle must be made of liquid magma. But Martian volcanoes aren't active anymore. There could have been a hot liquid mantle under the planet's crust once, but after the volcanoes formed, something went wrong. The interior probably cooled down, or the crust somehow became thicker. Whatever it was, it successfully stopped magma from getting to the surface. And then there's also seismic activity. If many Earth or Mars or Venus quakes happen on the planet, there's a lot going on under the surface. If we talk about Earth, it's the movements of tectonic plates. Most earthquakes happen along their edges. If there's little seismic activity on the planet, it might have no plate tectonics. Then its interior is calm. Researchers also pay attention to how long it takes a seismic wave to go through a planet or how it echoes inside. It can help to get more information about the density of the crust, what the mantle's made of, and so on. But scientists have to be extremely careful with the causes of these earthquakes. Sometimes they can occur after meteorites hit the planet, and it has no connection with the processes going on under the surface. Of course, these last two methods will only work with rock planets, mainly because gas giants have neither volcanoes nor seismic activity. Boy, all this talk about thin crust and thick crust is making me hungry. Hey, you up for some pizza? Not so long ago, astronomers discovered a planet that got the name of UCF 1.01. This world is about 33 light-years away from Earth. This makes the planet our next-door neighbor, in the cosmic scheme of things, of course. Honestly speaking, the space body is only a planet candidate because astronomers haven't measured its mass yet, but they have high hopes. The wannabe planet is very different from our Earth. Just 1.7 million miles away from its star, it completes its orbit in a day and a half. It's a scorching, deserted world with the temperatures at the surface rising up to 1,000 degrees. Even more astounding, the entire planet is likely to be covered in magma. Even if UCF 10 ever had an atmosphere, it has definitely boiled away by now. But then, the question is, what if Earth once went through some catastrophic event and it left our planet in the same state, boiling hot with the surface covered by a thick layer of lava? Would people manage to adapt to such conditions and move to live underground? It sounds unbelievable, but experts are sure that with time, humans would turn into healthy and rather happy mole people. Of course, life would be very different than today. No more sunsets and sunrises. No more traveling by plane and space exploration, unless people found a way to launch a rocket from under the ground. No more picnics in the park or sunbathing at the seashore. People would have to build a vast network of underground tunnels that would connect major cities. The most likely transport in this new world would be silent high-speed trains and electric cars. After moving underground, people would have not only physical but also psychological difficulties. In the beginning, their new home would be a dark, barren place, without fresh air and devoid of any color. To adapt to these tough living conditions, people would have to make some design changes. Greenhouses, well-lit parks with trees and illusions of the sky, familiar scents and sounds. All this would help people to adjust to their new life. After living underground for several generations, people would start to look a bit different. Pale because of the lack of sunlight, with sensitive large eyes adapted to dimmer lighting and more developed lungs. As for the very possibility of living underground, well, hear me out. You might imagine the Earth's depths as a huge mass of compressed solid rock. But the reality is different. This mass is heavily cracked. Water runs down the fractures and cracks in the planet's outer layer, the crust. Some of these streams reach the depth of many miles. In other words, subsurface Earth could probably support plant and animal life, If people lived underground, they wouldn't have a shortage of fresh water. Its reservoirs in the planet's interior contain 100 times more water than all the lakes, rivers, and swamps combined. Plus, this water trickles through the soil that acts as a purifier. But people would have to be super careful to keep the sources of water intact. Otherwise, the underground cities would get flooded and turn into giant water-filled traps. It would also be a great challenge to live without sunlight. Plants can't survive without the sun's ultraviolet light. It's absolutely necessary for photosynthesis because sunlight is used to get nutrients from carbon dioxide in water. One of the byproducts of this process is oxygen, the thing people can't live without. So, no sunlight equals no plants equals no oxygen. Sunlight is also crucial for humans. For example, it helps your brain release serotonin, a hormone that boosts your mood and makes you feel focused and calm. Thanks to the ultraviolet B radiation in the sun's rays, your skin produces vitamin D. It's vital for a strong immune system and healthy bones, teeth, and muscles. That's why people would have to find a replacement for sunlight. Luckily, LED lamps that can give off UV wavelength could produce the light human bodies and plants crave so much. In the new underground world, there wouldn't be large sunlit fields. Instead, there would be sprawling greenhouses with LED lights shining from the ceiling. Special machines would feed plants and crops with recycled water rich in nutrients. In some areas, located in the narrow underground faults, people would use something like shipping containers instead of greenhouses. These containers would be packed with vertical rows of plants and blue and red LED bulbs. As for people, they would have to follow a vitamin D-rich diet. It'd mean eating a lot of egg yolks, cheese, fish, spinach, soybeans, and so on. If these foods weren't enough, vitamin D supplements would do the trick. Without daylight, people would have problems with their circadian rhythms that regulate sleep patterns. If you were isolated somewhere without a glimmer of light, you would easily sleep for 48 hours at a stretch. That's why people living under the Earth's surface would rely on artificial lights to control their internal clock. There wouldn't be any problems with electricity. It would be produced with the help of the Earth's inner heat. Such kind of energy is called geothermal, from the Greek words geo, earth, and therm, heat. It can be extracted from hot water and rocks. Like an onion, our planet is made up of several layers. The innermost part is a solid core around 1,500 miles across. Made of iron, it's surrounded by a scorching outer core. It's up to 1,400 miles thick and is mostly composed of liquid nickel and iron. The next layer is the mantle. Even though lots of people picture it as lava, the mantle is actually rock. But this rock is so hot that it flows, just like road tar. The temperature in the Earth's core is as high as 10,800 degrees Fahrenheit. That's almost 1,000 degrees more than at the Sun's surface. The mantle is also blistering, from 7,000 degrees at the boundary with the core to 400 degrees in its outer parts. No wonder people wouldn't have any difficulties with transforming all this heat into electrical energy. But because the insides of our planet are insanely hot, people wouldn't be able to build cities too deep underground. All inhabitable areas would most likely stay closer to the surface. The Earth's outermost part, the crust, is like the shell of a hard-boiled egg. It's broken into gigantic blocks called tectonic plates. When two plates collide, mountains get formed and new rifts appear in the seafloor. They have different width, from 25 miles thick beneath the continents to 5 miles thick beneath the oceans. These blocks travel around, floating on the Earth's mantle, slowly, almost imperceptibly. It means underground cities would also move, but it would be next to impossible to notice these movements. Oh, by the way, people started to believe there might be another world inside our planet in the 17th century. The idea got the name of the hollow Earth theory. It claimed that half the planet was taken up by its surface weight. Below the surface, there was some empty space. A small sun hung at the very center of that cavity, creating a comfortable tropical environment on the inner side of Earth's surface. One could enter the Earth's interior through one of the openings near the South and North Poles. A race of advanced humans was believed to live inside the planet. They were peaceful and lived for centuries. Well, obviously not humans. They had unique technologies, for example, flying vehicles. And since the climate inside the planet was better than that on the surface, this race was much stronger and healthier. Even though this idea sounds like science fiction, several famous scientists supported it. Some people are still sure there's another world inside our planet. But if the Earth was hollow, it wouldn't have a magnetic field. And without a magnetic field, solar winds would rid our planet of its atmosphere in the blink of an eye. This would leave our green planet deserted and uninhabitable, like Mars is. The magnetic field on our planet exists thanks to the processes going on in its very much not hollow center. Liquid metals are constantly moving in the Earth's outer core, generating electric currents. When the planet rotates around its axis, the electric currents form a powerful magnetic field. The sunward side of the magnetosphere is as large as 10 Earth's radii, and the other side stretches out in a magnetotail that spreads for 200 times the Earth's radius. Okay, I officially give up on the hope that the moon is made of cheese after all. Wow, not even Gouda. The shiny lunar ball, or a curved banana, or half of a coin, depending on what phase it's in, has different layers inside, just like Earth. One of these layers is called the inner core. About 20 years ago, scientists were observing how the moon rotates. Using that data, they concluded that it had a fluid outer core. But the inner core was hard to study, so they didn't know if it was solid like a rock or molten like a hot liquid. But things are clearer now. Astronomers have collected data from different missions, including the Apollo missions, where astronauts went to the moon and gathered information themselves. Plus, they've used a special technique called seismic data. This method is all about studying how sound waves move through things. Take earthquakes on our planet as an example. When an earthquake happens, it creates waves that travel through the ground. Scientists can detect and analyze these waves to learn more about Earth's interior. The same idea can apply to other objects in our solar system, or planets, or, in this case, the moon. When quakes or moonquakes happen, they generate sound waves, and by carefully listening to and studying these waves, scientists can create a detailed map of what's inside the object. They can figure out things like different layers, what they're made of, and how they're arranged. To check the moon's deep interior, scientists also use something called laser ranging. This method measures the distance between the surface of the Earth and the moon very precisely. And ta-da! Our natural satellite's inner core is a dense, solid ball made of iron, just like Earth's. It's about 310 miles wide, which is nearly 15% the size of the entire moon. Researchers also have stumbled upon evidence that supports the theory that the layer between the moon's surface and its core, called the mantle, has been moving around as the moon evolved over time. This movement is something we call lunar mantle overturn, and it could explain why we find elements rich in iron on the lunar surface. Mantle material ends up being carried upward, and the volcanic rock remains in the moon's crust. Some of the materials in this rock were too dense, like me, so they just sank back through the lighter crust material all the way to the core mantle boundary. It's like a cycle where the moon's mantle material goes up during volcanic activity, carries iron-rich elements to the surface, and then sinks back down. There's another mystery scientists have been trying to solve. What caused the moon's magnetic field to weaken and nearly disappear over time? It seems that now that we know about the iron core and the global mantle overturn, we might get some more answers about the moon's magnetic field. Knowing what the inner core is like can help us better understand the moon's history as well as the history of our entire solar system. Now, one of the theories that's widely accepted about the origin of the moon says there was a massive collision between Earth, in its early stages, and another mysterious object in our solar system. It's called the Large Impact Theory, and this collision was so strong it ripped off a big chunk of the primitive molten Earth. I mean, not so big compared to what's left. If you put a US nickel next to a green pea, you get a good idea of how big our planet is compared to the Moon. Now, this chunk was set into orbit around our planet, and this might have happened about 95 million years after our solar system formed. The object that collided with Earth could have been about 10% the mass of our home planet and roughly the size of Mars. Well, it makes sense. Earth and the Moon do have similar compositions after all. Of course, there are other ideas about how the Moon formed. One says that the gravitational force of our planet captured it. This means that the Moon was just an object innocently passing by when suddenly it got attracted and pulled into Earth's orbit. There's even a hypothesis that Earth stole the Moon from Venus. Ooh. In that case, the Moon shouldn't complain. I guess the view is way better here. So yeah, the Moon and Earth are similar when it comes to rocks and some minerals. But the Moon doesn't have the same atmosphere as our planet. Its atmosphere is thin and consists of some weird gases that include potassium and sodium, which is not something you can find in the atmosphere of Mars, Venus, or Earth. And the rocks on the Moon don't contain water. But that doesn't mean there's no water at all up there. A long time ago, in the 17th century, astronomers saw large dark spots on the Moon's surface. One of these astronomers thought these spots looked like oceans, and he called them maria, which means seas in Latin. Other astronomers also made maps of the Moon, and they used the term maria to describe these dark spots. For example, Mare Tranquillitatis translates to Sea of Tranquility, where Apollo 11 made its touchdown. But it seems those dark spots are not actually oceans. They are plains made of hardened lava that erupted long ago. These volcanic eruptions left behind smooth flat areas called basalt plains. In the late 1800s, one sky watcher studied the Moon and found it didn't have an atmosphere. Without an atmosphere, there are no clouds and no air to keep water from evaporating. So scientists thought that any water on the Moon would just disappear right away. They believed the Moon was totally dry. But then, in 1961, one physicist had a different idea. He pointed out there could be water on the Moon in special areas called permanently shadowed regions. These are spots on the Moon where the sun doesn't shine, so they stay dark all the time. Water ice could exist in these dark areas because they're extremely cold and the ice wouldn't evaporate. But when astronauts from the Apollo missions went to the Moon, they brought back soil samples, and scientists found no signs of water in them. So everyone went back to thinking that the Moon was completely dry. In the 90s, NASA focused on these shadowed craters and found high concentrations of hydrogen, which meant there could be ice at the Moon's poles. They still weren't certain, so they kept digging and after a while found hydrogen trapped inside tiny beads of volcanic glass. Since there are no active volcanoes on the Moon today, which means water probably was present on the Moon when these volcanoes erupted long ago. Plus, there could be way more water back in the early days of our Moon. In 2020, NASA's SOFIA mission showed us what we'd been looking for a really long time. There is water on the Moon after all. It turns out the water is hidden within the grains of lunar dust or sticking to the surface in the sunlit areas of the Moon. So there are no oceans like we have on Earth, but at least there's something. The question remains, how did water even get there? It seems the Moon had a chaotic history back at the time when it was forming, as probably most of the planets and moons in our solar system. So there is some evidence that water came there from comets hitting its surface back in the old days, or maybe even keeps on coming from those that are slamming into the Moon right now. We're talking about a chaotic situation where icy micrometeorites collide with the Moon's surface, and dust then makes an even bigger mess when interacting with the solar wind. But we're waiting to find out more about this. Because, as we all know, when you mention water, you also inevitably talk about life. That's why we want to know more, for instance, about all that ice hidden in polar craters on the Moon. Maybe it can teach us more about how life developed on Earth. Maybe comets brought all the necessary elements here. Then, what if there are some of those elements stuck in the ice on the Moon, too? soaring temperatures of more than 11,000 degrees Fahrenheit, solid rocks of blazing superhot fire, immense pressures 3.5 million times stronger than on the surface of the Earth. These are just some of the things cooking 1,800 miles beneath your feet as you're watching this video. How? The Sun is burning with a temperature similar to our planet's core, but it's 93 million miles away. So why isn't Earth melting away from its own core? Our little blue planet is made of many layers stacked one upon another. The inner core, the outer one, the mantle, and the crust. The deeper you go, the hotter and more pressurized it gets. Plate tectonics are layers of the mantle and crust piggyback riding, forever moving and just having a good time. Scientists discovered there are 9 plates in total in different parts of the world. When these plates move and grind on each other, earthquakes occur. Energy is released as a result, and we feel it on the surface. Think of it as trying to shut a car door after stuffing it to the brim. When you realize there's something in the way, remove it and boom, everything topples. Billions of years ago, our lands were all interlocked in what was called Pangea. But slowly, and I mean slowly, over the years, the continents drifted apart into what we have right now. The Earth was also cooler on the inside, but it slowly started generating more heat in the core. Earthquakes are measured with intensity and magnitude. We see how far the effects of an earthquake reach through magnitude, and the intensity is the measure of its power. Over at the mantle, the cooler rocks begin sinking, and hot material from the core rises up. When this happens, the plates begin moving, and as a result, they create mountains, hills, and bodies of water we have today. None of these things happen overnight. It takes millions of years to actually see something. All the way in the layers of the Earth, there are different sources of heat, mainly from when the planet was initially formed. Friction heating occurs when materials begin sinking down to the center of the Earth. Since the Earth is surrounded by a solid mantle, the crust floating on top of it acts as a barrier to protect us from the Earth's insides. But the secret for its success is the difference between heat and temperature. Simply put, heat is just energy, and temperature is its density. If the Sun was 1,800 miles away from the surface of the Earth and boiling at the same temperature as our core, we would melt like ice cream on a hot sunny day. A shock from a small short circuit when plugging out your phone charger from the socket won't be too harmful, even though a spark can have temperatures of around 2,700 degrees. But if you dipped your body in a boiling bath of hot water at around 200 degrees, let's just say it's not worth it. Just because the temperature of the Sun's surface is roughly the same as the Earth's core, doesn't mean the heat distribution is the same. The Earth's core is teeming with iron throughout the layers, but on the surface, the iron atoms are arranged into cube shapes. That's when iron is in normal room temperature and regular pressure. But put in extreme conditions, the atomic shape changes into hexagons. For a long time, scientists thought that the iron in the core was hexagon-shaped, but they found out it retained its cubic formation 1,800 miles underground. Since the core has so much pressure, the atoms simply don't have a place to move to change their shape. If you were standing in a subway train that was packed full, you wouldn't even have space to lift your arm. But everyone inside is able to switch positions while keeping the original shape. That's why the structure of the Earth's core is solid and not liquid. The atoms are so tightly packed that they can't even transition into a liquid state. But in a world where the Earth's core liquefied, we'd witness the worst consequences, starting with major and mass volcanic eruptions, earthquakes, and tidal waves. Every major hotspot would be in danger, and the ring of fire would be a non-stop fountain of lava spewing out. Cool material from the upper layers sinks down to the core and vice versa. With a liquid and incredibly unstable core, this process would be much faster. Every major city and town by the coast would be washed away by tidal waves, and all the volcanoes erupting will blacken the sky with ash and smoke. This would temporarily block the sunlight from entering our atmosphere and eventually force anything flying in the air to remain on the ground. The lands we currently live on would feel like ice breaking away from a glacier and floating off. Many dormant volcanoes would wake up from their slumber and spew out their morning lava all over the place. The ground formation and structure would change permanently. Magma from the bottom of the ocean trenches would find its way up to the surface and change the currents in the oceans. The Arctic Ocean and Antarctica would melt away and add to the rise of water levels all around the northern and southern hemispheres, and eventually the world. Wildlife on land wouldn't be able to flourish, and all the greenery would disappear. Marine life would have to find a way to escape the changes in the ocean temperature. The world economy would crash as an international emergency would be declared to try and figure out a way to stop this. But humanity would barely make it alive and would have to strive to continue existing. Well, of course, something like this will never happen. But if the Earth's core cooled down, then we wouldn't have massive volcanic eruptions, no devastating earthquakes nor tidal waves. In fact, none of these things would happen since they require energy to function. The continents would stop moving and changing. Sounds cool, right? No. This means that the magnetic field protecting our planet would disappear, which would make us extremely vulnerable to cosmic radiation, as well as asteroids and meteorites. The sun's rays will feel even more intense than usual, which will make it extremely unsafe for anyone to go outside. The heat produced in the core is responsible for recycling the carbon that goes back to the surface. Now, recycling would stop altogether. Carbon is an essential part of carbon dioxide that plants need to survive. So all the trees and plants on the surface and in the water would stop growing and wouldn't be able to produce oxygen for the rest of the world. With cosmic radiation and lack of oxygen, humans would have to live in bunkers with artificial ventilation systems. The Earth's surface would become a no-go zone and start to resemble Mars. With nothing to power the Earth from the inside, it'd begin to dry up and crumble internally. Much of the Earth's surface is made out of oxygen, so without it, we would eventually see something like major sinkholes around the world. Sinkholes that can take down cities like New York and Paris, along with landslides in many cities and unstable landscapes all over the place. Every single city's infrastructure would eventually collapse and make the ground unwalkable. So even if you did live in an underground bunker, chances are the foundation wouldn't last and you'd be exposed to the cosmic radiation. But all of this can vanish in the blink of an eye if an asteroid comes falling down. Whether it's tiny or colossal, we would be seeing more of those than actual rain. Without a magnetic field, the Earth can't block any foreign object that flies through our atmosphere. If an asteroid the size of Rhode Island came falling down, the damage would be much more than with the Earth's core hot and running. With the ground as fragile as potato chips, the ripple effect would be much wider and cause more indirect destruction around us. The Earth would eventually collapse in on itself and break into pieces until it's lost its own gravitational energy. It'd end up being a bunch of rocks and pebbles floating around in the emptiness of space. But nothing like that will happen either. We're living fine with our solid hot Earth core. As long as it's doing okay, then we can keep on doing our thing.
Hey, I want to show you something. Let's take a little trip off of Earth and park our spacecraft somewhere near the moon. We're now almost 240,000 miles away from our home planet. That's almost 100 times the width of the United States. Now we've brought a special set of tools with us, a giant hammer and an enormous chisel. Place the chisel at the Earth's North Pole and strike its head with the hammer. The Earth cracks open like an eggshell and we see another planet. This is Theia, and it's hiding inside our planet like a yolk in an egg. If you want to find out how it got there, you need to travel back in time 4.5 billion years. This beautiful nebula is what will eventually become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Over time, this jigsaw puzzle of debris becomes denser and heavier. The temperature inside the giant is rising. Soon, it gets so high that it'll trigger a nuclear chain reaction. One more second, and bam! There's an explosion so powerful that the shockwaves travel far into deep space. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. But we're interested in that small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core while the oceans of lava are gradually cooling down. But some millions of years later, after the sun's birth, you notice another small object. Here comes Theia. This small planet was formed at about the same time as Earth, and right now, it's following a crazy spiral trajectory at enormous speed. Scientists believe Theia was like a ball Jupiter and Venus played around with. Venus would pull Theia in one direction, and then Jupiter would pull it right back. But what makes up 99.8% of the mass of the solar system is the Sun. It's what makes Theia move into almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Theia is roughly the size of Mars, as wide as the Atlantic Ocean from New York to Portugal. At this point, the collision can't be avoided. Theia is traveling towards Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If this smaller planet would crash into Earth at a particular angle, Earth would most likely be torn apart, as well as Theia itself. The collision would cause a huge blast visible on other planets, even on a bright day. Nothing would be left but some burning dust and debris. Even if Theia only slightly grazes the Earth, it'll still knock out a sizable chunk. But the collision with Theia happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shockwave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site, which soon gets filled in with boiling lava. The remnants of Theia and the ejected fragments of Earth begin to orbit our planet. According to one theory, these fragments actually form two moons. At first, they travel together, but one day they get too close to each other and collide, forming one large space body. The other theory claims that all the loose shards get pulled in by the remnants of Theia, and that sometime after that, they form the moon, as we know it today. At this point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Theia that we have different seasons and 24 hours in a day. Now, Earth also has these things called lithospheric plates. These are enormous solid land masses that make up the crust of our planet. After the collision with Theia, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet, so Earth gains a kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over the next nearly 4 billion years, simple single-cell organisms evolve into the kinds of complex life you see today. According to scientists, a collision like we had with Theia is a very rare event. The probability that somewhere out there there's a planet like ours that has survived the same catastrophe is even rarer still. This may be the reason why we have yet to find other traces of other civilizations out there in space. Meanwhile, the remains of Theia are still here on Earth. Of course, it doesn't look like an actual entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see two huge lava blobs the size of large continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Theia. They didn't mix with the Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise these lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Theia might be on the moon. The Apollo space missions brought back many soil samples for analysis, which led scientists to conclude that the moon is very similar to the Earth in structure. Someday in the future, people could drill deep down and take samples of the moon's crust. Then they'd analyze the blobs from Earth, and if their structure matched, it would be undeniable proof that Theia did hit Earth 4.5 billion years ago and gave us the moon. But for the time being, Theia remains an unsolved mystery. Scientists are still not sure that the planet actually existed. The whole idea does perfectly fit the model of the moon's creation, but it's also possible that this incredible collision may have never happened. Now, let's travel 41 light years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. Let's take out our giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than on Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon, and the structure changes. First, it turns into graphite, but then add just a bit more pressure, and the graphite turns to diamond. On Earth, diamonds form at depths 60 miles below sea level, where the pressure is 50,000 times greater than that on the surface. And the temperature there averages over 1,000 degrees, which is as hot as fire. Diamonds are often ejected closer to the surface in volcanic eruptions, but still, people mostly have to dig mines 1,500 feet deep to find these beautiful gems. Currently, the Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now, imagine a diamond the size of an entire planet! Now, let's fly back to our solar system. Our destination now is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% of the mass of Earth. Its surface is enclosed in an icy crust that's about 19 miles thick. Europa is completely covered in water. It's freezing here, 3 times colder than that of the North Pole and Earth. The water turns to ice almost instantly, but the ocean beneath the surface is still liquid. Europa has a gravitational relationship with Jupiter, just like the moon with the Earth. This creates tidal forces that heat Europa's core, which then melts the ice around it. The result is a huge ocean, 2 or 3 times larger than that of Earth's oceans combined. Scientists believe that water is one of the essential ingredients for life. This means that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans, though the water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria could live there. Europa is almost the same age as Earth, so there has been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They might be building big cities and dreaming of conquering space. But for now, all we can do is speculate, and maybe someday send the probe to Europa to find out if life is possible there.
Now, let's pretend that humanity faces a huge threat from outer space. So we'll imagine that a giant planet-eating octopus comes to our solar system to eat Venus, Mars, Earth, Jupiter, and other planets, except Saturn. Therefore, people decide to move to the big planet with giant rings. Fortunately, they already have cool technologies that allow them to make such trips. So we get into giant ships, take off, and fly to Saturn. Life on the planet itself is impossible because it has no solid ground. The ship won't be able to land there. This is a giant gas ball that is 9 times wider than Earth. To compare their sizes, look at a 5-cent coin and a baseball. And the planet's atmosphere consists mainly of hydrogen and helium. So if the ship starts to land, it'll never reach solid ground. And the lower it goes, the higher the pressure it will experience. Eventually, the ship will just be crushed. Therefore, we have only one choice: the rings of Saturn. They're made up of giant, medium-sized, and tiny particles of ice and rock flying around the gas giant at tremendous speed. They were formed from comets flying by. Saturn's gravity knocked these celestial bodies off their course and crushed them with its pressure. Fragments of these comets began to accumulate around Saturn, forming rings. Now, some of these particles fly faster, some are slower. The closest to the planet is the D ring. It's followed by rings C and B. Then there's a large gap called Cassini division. Rings A, F, G, and E come after. This classification is very convenient for creating a ring map. So people approach the rings, but don't dare to land on them. First, they send test capsules with robots to scout the area. The robots choose a suitable location on the E ring. In fact, the distance between the rocks is quite large, and the ship can easily fly there. There are tiny particles, huge rocks the size of houses, and comets the size of a whole mountain. The first robot flies up to a large rock at high speed. At this moment, a baseball-sized stone pierces the robot's body. Another robot gets smashed between two colliding boulders. The third robot gets caught in a rain of sharp icicles and breaks. People have big engineering workshops on their ships, so they build new capsules and new robots. This time they're made of more durable materials, so the robots reach a big rock again. A few particles crash into them but don't break through the armor. The machine set up a small station on a flying rock where people can live. But after a couple of hours, a big chunk of asteroid smashes the station. Well, seems like we need another strategy. Giant ships scan the entire area of the E-ring and calculate the trajectories of billions of stones. After lengthy calculations, people finally find the perfect places in the middle of this chaos that will stay intact for a long time. They land on these large rocks in their capsules and begin to settle down. They build stations and small houses and install powerful batteries on them. Saturn is located at a distance of 9.5 astronomical units from the Sun. 1 unit is the distance from the Sun to Earth. So, Saturn is a pretty cold place. That's why there's so much ice flying around it. But how to get the energy to heat it all up? There's too little of it on large ships. Besides, solar panels are ineffective here because of the great distance from the Sun. Therefore, scientists create a way to generate kinetic energy from flying stones. It's like a windmill. When the wind drives the fans, these movements are converted into energy. So engineers build panels that collect power from the moving stones. But it doesn't slow the speed of rocks down because Saturn's gravity continues to move them. Thus, people receive a source of almost limitless energy. Some space stations have plants and trees that produce oxygen through photosynthesis. Only instead of sunlight, they get energy from ultraviolet. Then people fill large tanks with oxygen and carry them to their homes. People begin to occupy the adjacent rings. You don't need a lot of fuel to get from one place to another. You can land on a rock, calculate its route, and wait for it to bring you to the needed point. Then you can move to another one, and so on until you reach your destination. More and more people leave their ships and move to the rings. It seems that life is getting better, but then psychological problems begin. Constant movement in the vacuum of space drives everyone mad. Imagine living on a carousel that never stops. You can't walk to the store whenever you want because it always flies away. No one can go out for a walk, even in a spacesuit, because there's a chance to come across a rock flying at high speed. You can't plan anything because, at the moment, your plans can be ruined by a giant piece of ice. Computers don't help either. They can't calculate the trajectories of all space bodies. Rocks tend to break and split into hundreds of smaller ones. Also, new comets fly by and also become part of the rings. All this creates uncertainty and causes a sense of anxiety in people. Besides, it's dark, cold, and very lonely on the rings. Now think about building a base on a space object, but your best friend lands on another one a few miles away. Then, a giant icicle crashes into his rock and increases its speed. And a few days later, your friend is too far away. And it happens all the time. The only way to change your life is to settle on one of Saturn's moons. The planet has 83 of them. People have already confirmed and named 63, and the existence of 20 others has yet to be confirmed. They're all like different worlds. Some of them may be habitable, and the best candidate among them is Titan. There may be water on it, and its atmospheric pressure is only 1.5 times greater than Earth's. Its atmosphere consists of nitrogen and a little methane, forming carbon smog in Titan's upper layers. For this reason, we can't study this moon from Earth. But the coolest thing is that Titan flies outside the rings of Saturn. This means people can lead a quiet life there. There's also satellite Phoebe, covered with craters like our moon. This giant celestial body looks more like a gigantic meteorite. People have a lot of choices of where to start a new life. During a couple of hundred years spent on ships near Saturn, humanity would learn everything about its satellites. But why did they try to live on the rings? Why didn't they land on one of the moons from the very beginning? Because, well, then this video would be less fun and a whole lot shorter. But what if we were initially born inside the rings of Saturn? Let's say a massive meteorite with frozen water got caught by the planet's gravity. There were the simplest life forms inside the ice, and then this life began to acquire more developed forms. Imagine that the large rock managed to remain untouched for hundreds of millions of years, and during this time, humans appeared. But of course, they would be very different there. Firstly, they wouldn't experience gravitational forces. This would make them taller but weaker. People's skin would be pale because of the lack of light, but very hardy thanks to cold temperatures. Particles of ice and grains of sand flying in space would roughen people's skin. In such biological armor, without gravity, they would jump from one rock to another in search of food and water. And, by the way, that would be the main problem. How would people survive without oxygen in the vacuum of space? Where would they get their food? Saturn's rings are a pretty lifeless and dangerous place. If there are not even the simplest forms of life there, then how could such a complex one as the human appear? Therefore, even in theory, the appearance of people would be impossible there.
If humanity needed to leave Earth, where would we go? Could our next home be some giant construction hanging out there in space? Something like the Stanford Torus. This design was proposed by NASA in 1975. It's a space habitat that can house 10 to 140,000 permanent residents. It's supposed to be a completely self-sufficient colony. People living there will be able to produce their own food, have their own manufacturing, and build high-quality and comfortable residences for the inhabitants. As you can see, the colony is basically a torus with a diameter of a bit more than 1 mile, and the habitat tube itself is around 1,410 feet across. Pretty much space to stretch your legs, I'd say. The ring is supposed to be connected to the hub with the help of a few spokes, which will be needed to transport people and materials traveling to and from the hub. This hub will be at the rotational axis of the station, which means it will experience the least artificial gravity. So it will be the easiest location for spaceships to dock. For the same reason, the zero-gravity industry will be performed in a non-rotating module attached to the hub's axis. The torus will be used as living space since it is large enough to simulate a natural environment. It looks like a long, narrow, straight glacial valley with its ends curving upward and eventually meeting overhead to form a circle. The population density on the station will be similar to a densely populated suburb of a large city. Some parts of the torus will be dedicated to agriculture, others to housing. The torus will weigh almost 10 million tons. During the construction, they might use materials extracted from the moon and sent to space with the help of a mass accelerator. Only those materials that can't be obtained from the moon will be imported from Earth. Another source of materials might be asteroid mining. The torus will rotate at 1 revolution per minute. It's vital for creating artificial gravity. People and other living organisms can't withstand the absence of gravity for very long periods of time. But who knows, maybe with a space base as our new home, we could adapt to weightlessness. Anyway, there will be a stationary mirror positioned at 45 degrees. It'll redirect sunlight down to the colony. The inner disk of the torus will act both as a docking bay and a solar generation area. Approximately 6 miles away from the station, there will be a tethered power generation satellite, providing additional power needed for the colony. There will also be a large, flat, stationary radiator sitting below the inner disk. It will help dissipate waste heat from the station. All the energy necessary for the functioning of the Stanford Torus will come from solar power. People will use it for agriculture, illumination, and heating the station. Electricity generated from solar energy will also be used for everyday life, for example, for powering household appliances and for supporting interior lighting. The idea of Stanford Torus was proposed during the 1975 NASA summer study, which was conducted at Stanford University. The main goal of this study was to explore and speculate on designs for future space colonization. Whether this project can be built in real life and whether it can actually be functional is still up for debate. but the analysis, based on modern solar technologies, claims that a large structure in space might indeed be supplied with electricity through solar power generators. Interestingly, Stanford Torus refers only to one particular version of the design, and the concept of a ring-shaped rotating space station appeared at the beginning of the 20th century.
A space settlement floating out there in the cosmos. It's not sci-fi. But, as always, there is a catch. Look at this tiny deserted asteroid. It may look lonely and barren, but if you peek inside, you'll see life blooming inside of it. These days, many people now live right inside these asteroids. It's not sci-fi. According to researchers, we might be able to create futuristic cities the size of Manhattan on gigantic space rocks. Of course, there's a catch. The asteroid we choose as our base has got to be at least 1,000 feet wide. Though it's weird why life is inside this asteroid and not on its surface. You see, we can't really live right on asteroids. That's because we're not the little prince who indeed lived on an asteroid, according to the plot, but because there's too little gravity and too much radiation for us to handle if we chill outside. There are possible theoretical ways to stay on the surface, but it's going to be extravagant. So the only option is living inside asteroids. Nothing screams wildly theoretical like building an asteroid city. Living in space without any gravity isn't as romantic as it sounds. Researchers show that when people spend too much time in zero gravity, things start getting weird. Their eyeballs pop out, retinas detach, muscles shrink, and bones become as fragile as a potato chip. But imagine this, a space settlement floating out there in the cosmos. If you've watched enough sci-fi, you'd picture a massive structure spinning round and round. It spins to create gravity for all the lucky folks living inside. There's an actual prototype of this wizardry, the O'Neill cylinder. This device is named after physicist Gerard O'Neill, who came up with the idea for NASA in the 70s. Now, there isn't a ton of data on this, but humans need roughly 1/3 of Earth's gravity to function properly. An O'Neill cylinder may not be able to generate massive amounts of gravity, but the genius behind it, Mr. O'Neill himself, designed them to spin around their long axis. This device creates a gravity-like force called centrifugal force. So, if we ever get to use that, we'll be living happily on the inner surface of the cylinder, feeling pulled downward away from the center. But, as always, there is a catch. When the team crunched the numbers, they realized that the asteroids would break apart way before they could reach the speeds necessary to keep us grounded. And to make matters worse, most of these asteroids were more like loosely assembled piles of rock than a solid chunk. The small ones, like less than 6 miles across, are a mix of sand, pebbles, rocks, and boulders. They're all held together by the weak force of their own gravity. If you were to spin one of these asteroid buddies, all those parts would go flying off into space. Not cool. However, scientists didn't give up and they elaborated on the idea. They needed to find a way to keep the asteroids together. They played around with different ideas and they produced something crazy. Now, if you were to carry all your personal belongings every day right in your hands, at some point, the situation would be out of your control. You'd have to collect all your stuff from the floor. But you're smart and you carry a bag, right? Well, it seems that if we want to control an asteroid, all we need is a ginormous bag. But not just any bag, a massive, flexible, and super lightweight mesh bag made from teeny-tiny carbon nanofibers. These fibers are like tubes that are only a few atoms wide, but boy are they strong. So once we've got this cylinder-shaped bag all set up, we can start slowly spinning the asteroid using rocket motors deep within the rubble. And as it spins faster and faster, it'll start flinging all those pebbles, rocks, and boulders. And guess what? The carbon nanowire webbing is going to go flying out with them. This bag will be expanding and expanding until it reaches its absolute limit. And then the rubble inside slams into the now super tight webbing. It's like a crazy explosion of debris compacting together to create this massive hollow cylinder made entirely of concrete. Once all the dust settles, you can build entire towns, cities, parks, and even farmland on the inside of the cylinder. This is like something straight out of O'Neill's designs. You can even enclose the whole inner surface with a transparent roof. Outside of this incredible living area, you've got these thick concrete walls that are like superhero shields protecting against radiation. So not only do you have this space to live in, but you're also super safe from any harmful stuff outside. We still don't have this magic bag, as those magic carbon nanowires aren't mass-produced yet. But scientists claim that, according to the laws of physics, a tiny asteroid, like a few football fields put together, can be transformed into 22 square miles of living space. As of now, about 1.5 million people are living in Manhattan, and there are like tens of thousands of asteroids just hanging around in our solar system. You do the math. Seems like everyone will have a sweet spot to crash in space. Building a city in space is no easy feat. The main challenge still is to create a self-sustaining closed system that can keep going for the long haul. You see, cities on Earth rely on a much larger area to survive than just their own boundaries. But in space, the farther away from external resources a space city is, the more it needs to close its loops for oxygen, water, and food. Take the ISS, for example. It's about 40% efficient in recycling oxygen, but even then, its CO2 levels are always sky high. NASA is on the case, though, trying to figure out how to magically turn that CO2 back into oxygen. Once we've tackled the basics, like protecting ourselves from radiation, dealing with pesky gravity, and finding some air to breathe, it's time to get creative in space. Enter 3D printing and rocket engines, the dynamic duo that will pave the way for space settlements. With 3D printing, we can kiss goodbye to relying on Earth for spare parts. We'll simply whip them up locally, cutting out the middleman. We can even use 3D printers to whip up a delicious pizza in a couple of minutes. Of course, we'll need some fresh ingredients, but your dinner might just be a push button away in space. To truly thrive out there, we'll need to tap into the riches of asteroids. These celestial treasures are bursting with raw materials, perfect for creating solar arrays, building materials for our colonies, and so much more. And let's not forget about comets. These icy wonders are like cosmic water fountains, providing us with precious H2O for drinking, bathing, and even shielding ourselves from radiation. Plus, we can use that water to produce hydrogen and oxygen for rocket fuel and fuel cells. So, let's say we pull this off. Can you imagine people living or born in space might end up being different from you and me? Like if humans can have babies up there, these space colonies might develop some cool cultures. They might even come up with their own languages, and get this, they could even evolve new physical traits. It's wild to think that just after 300 years, a colony of 2,000 people could look and act so differently from us. They might have different hair textures, skin types, and even be taller or more slender to deal with that low-gravity situation. We might even develop new organs to protect us from cosmic rays. Or we'll have gill-like structures to breathe carbon dioxide. Hey, I know, it sounds crazy, but these scientists are working on developing these carbon nanotubes as we speak. So maybe one day we'll be living it up on our very own asteroid crib. It might seem like asteroid cities are just too far-fetched, but let's take a trip back in time for a moment. In 1900, no one had ever flown in an airplane. But today, thousands of people are zooming through the sky, comfortably seated in chairs, traveling at hundreds of miles an hour high above the ground, unaware that their luggage is on another plane going to a different destination. Ah well.
You wake up with a start, feeling disoriented. You were dreaming of waterfalls and green fields just a moment ago, but now your body is tingling weirdly. It feels as if you don't have enough oxygen to breathe, which makes you panic a bit. You open your eyes and look around. Oh, you're inside your sleeping capsule. Whew! Its walls are littered with different buttons and tiny screens. You press one of them, and one of the sliding panels sweeps to the side. You crawl out of your pod. The absence of your windows or any natural lighting makes you feel as if you're underground. Dozens of sleeping capsules line the walls. The door leading out of the dorm is made of metal. It looks heavy and unmovable. But once you press the button on the wall next to it, the door opens smoothly and soundlessly. After walking up a dimly lit corridor for a while, you find yourself in a smaller room. There's at least half a dozen bulky spacesuits inside. There's another door in the room. It looks even sturdier than the previous one. If you wanted to open it, it wouldn't budge. First, you need to put on one of the spacesuits. As soon as it's on, the door automatically unlocks. After waiting for a while in an airlock chamber, you finally make a step outside. You look up and see a beautiful blue orb. It seems to be glowing. It's Earth, and you're standing near your home base on the moon. You walk towards your Jeep. It looks nothing like cars on Earth, though. The vehicle you climb into is pressurized, and you can even take off your spacesuit, or at least your helmet, and ride in comfort. If you need to go outside, well, yes, you can't do it without wearing your protective gear. One of your favorite rovers, produced by Toyota, is the size of 2 microbuses and can easily fit 2 passengers and their gear. Of course, you've got the experience of riding it with 3 other companions, but duh, you were squashed like sardines that time. The vehicle can also unfurl solar panels to generate power. After dealing with all the tasks you had on your list, you come back to your lunar home. Unlike your house on Earth, it looks more like a castle. Due to the extreme temperatures on the moon, the lack of oxygen, the constant threat of meteorites, and the never-ending barrage of radiation from the sun, it has to be super sturdy. The thing is, on Earth, we're protected by the atmosphere. Most meteorites burn while passing through it, and it also protects Earthlings from harmful ultraviolet radiation and creates the pressure without which liquid water couldn't exist on the surface of the planet. On the moon, there's no atmosphere like that. The very weak one that exists on our natural satellite is made up of some unusual gases that haven't been found in the atmospheres of Earth, Mars, or Venus. That's why people living on the moon have to take care of these issues themselves. The first towns on the moon were built in craters and covered with protective materials, like plastic reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants had to access their homes through airlock entrances dug into a mound. Bilbo Baggins would surely appreciate their aesthetics. On the moon, gravity is way weaker than on our home planet. And while it makes it easier for you to walk and even run on the satellite surface, even despite your bulky spacesuit, it's not great in the long run. That's why inside lunar bases, there's an artificial gravitational field. Without it, people would have problems with coordination, balance, and orientation in space. Plus, weight-bearing bones would lose 1% to 1.5% of mineral density per month. And there would be many other problems with health. Anyway, these days, along with old settlements located in craters, there are new towns that look like transparent glass spheres. They make a beautiful picture when you look at them while approaching the moon after visiting your family on Earth. Next to many of these domes, you can spot tall sun-reflecting towers. They can simulate the day cycle to help human bodies function properly, as they used to be on our home planet. Inside, there's a breathable atmosphere and fixed atmospheric pressure. The floors look as if they're made from regular concrete, but the material used in the construction is lunar dust. A colony on Mars would cost us trillions of dollars to construct and inhabit. It would take a long time for even one cargo ship to reach the red planet. But lunar towns are much easier to build and maintain. There are direct spaceship routes connecting the satellite with Earth. And you need just 3 days to travel between these 2 points. That's one of the reasons the colonies on the moon are growing, developing, and changing non-stop. When people first came to the moon with the intention of building settlements, their main concerns were producing energy and getting oxygen and water for a comfortable life. Now, you have trash can-sized nuclear reactors that provide the towns on the moon's surface with steady power. Plus, in some regions of the satellite, for example near the South Pole, there is near constant sunlight, which is great for getting solar power. That's one of the reasons why most lunar settlements are built in that area. Another thing that makes colonizing the moon easier is its ice. People living on the satellite use it to make hydrogen-oxygen rocket propellant. The main way to get the raw material is by using the regolith and ice drill for the exploration of new terrains. That's a piece of equipment designed for drilling in ice-cemented regolith and rock. This fuel is then used for cargo and passenger ships coursing between Earth and the Moon. Right now, people are trying to derive oxygen and other useful products from lunar soil. More than 40% of the lunar crust is composed of oxygen. Of course, it's bound up in minerals in combination with other elements. These compounds are called oxides. You might have heard of quartz, aka silicon dioxide. It's the second most common mineral in Earth's crust. To move from one lunar town to another, you use moon Ubers, taxiing people and cargo. They're also called all-terrain hex-limbed extraterrestrial explorers, or athletes. They have 6 limbs that can grip cargo and roll or step over obstacles. Plus, they can switch out quick connect gripping and digging tools if you need them. They also carry people to and from launch pads, acting as lunar airport shuttles. But lunar towns aren't just placed where people live. They're innovative research hubs both for industry and science. They're also a popular tourist destination. Plus, people living there are tirelessly working on developing and constructing a special base for future Mars missions and the exploration of distant space. But let's have a look at how it all started. For instance, how the first lunar bases were built. Private landers descended on the surface of the moon and deployed inflatable modules, each around 4 stories tall. They served as residential areas, workspaces, industrial sites, and scientific labs. But those modules couldn't completely protect their inhabitants from harmful radiation, temperature swings, and the strikes of micrometeorites. So, people developed robots that could 3D print protective shells around each inflatable module. They used readily available regolith taken from the surface of the moon. It took the robots about 3 Earth months to finish solid domes. Some of these settlements were later connected with one another through a series of walkways linked to airlocks in each dome. At the same time, some of the towns remained separated, like those constructed in craters. When you visit Earth, you often look up at the sky, searching for your new home. Some of the lunar bases are visible if you're looking at them through a telescope. Others, partially hidden underground or covered with lunar rocks and soil for better protection, are almost impossible to spot.
All right, let's imagine that humans have evolved to survive on very little oxygen. That means the Earth is now a no-go zone for us. And let's say that now we can live only on planets with little to no oxygen. It's time to build new homes on Mercury and Jupiter. So let's explore what life would be like if that happened. As you set foot on Mercury, you'll immediately notice how crazily bright it is. Mercury, being the closest planet to the Sun, is a never-ending summer vacation. Right now, it's scorching hot at a sizzling 800 degrees Fahrenheit. But since we don't need any water or oxygen, our bodies have adapted to the blazing heat and dry conditions of Mercury. Instead of overheating, our skin possesses a special protective layer that helps us handle these conditions. So, we're able to live there without any discomfort. How cool is that? On Mercury, the air is very thin. As a result, the sky there appears mostly dark and empty. The surface, however, is pretty colorful. It can appear orange and golden due to the planet's rocky terrain and the intense sunlight. All this creates some captivating views. Our activities would be super exciting. The gravity on Mercury is very weak, almost 3 times weaker than Earth's. So, imagine gliding through the air with incredible wingsuits. effortlessly soaring above the molten landscapes. So many possible cool tricks to show off. The buildings in this world are both imaginative and practical. They're made of special materials that can handle the heat and shine with a metallic gold color, reflecting the scorching sunlight. As you can see, our life in this small, hot world can still be pretty exciting. But let's move on to Venus. Now we've got ourselves quite a workload. This is the wildest and wackiest planet in the neighborhood. Temperatures there sizzle at a mind-boggling 900 degrees Fahrenheit. But guess what? Our bodies are cool with it. We can handle extreme temperatures. The winds there are crazy fast, reaching speeds of 224 miles per hour. Amongst them, we spot mysterious dark streaks that refuse to budge. Even scientists are puzzled by these streaks, which soak up ultraviolet radiation. It's like Venus has some secret party tricks up its sleeve. And speaking of parties, the planet is packed with active volcanoes, and they're always putting on quite a show. Molten lava flows and fiery eruptions are our daily dose of entertainment. Venus is similar in size to Earth, so the landscape feels familiar, but with a twist. It has a crazy amount of pressure that would make even the toughest creatures on Earth squirm. But not us. Our bodies are built to handle it, and we confidently strut around Venus like it's no big deal. Our cities shine like beacons, built with materials that can handle the intense heat and pressure. The metallic structures reflect the fiery glow of the Venusian sun. Inside, we've got super advanced cooling systems that keep us comfy despite the scorching temperatures. We surf on streams of molten lava, safely of course, and explore the volcanic landscapes. Pretty exciting, isn't it? But still, how about moving to a more friendly environment? Like Mars. Moving to Mars is one of our biggest goals. Its surface is a colorful canvas with hues of brown, gold, and tan. It's covered in rusting iron, regolith, which is like Martian soil, and dust. We would also be surrounded by volcanoes, impact craters, crustal movement, and mighty dust storms. As we gaze into the sky, we're greeted by Phobos and Deimos, Mars's moons. The sky itself is hazy and painted in shades of red, and becomes blue during the sunset, opposite to what we have on Earth. The temperatures on Mars can be quite extreme. Sometimes it's as mild as a comfortable 70 degrees Fahrenheit, while at other times it plunges to bone-chilling lows of around negative 225 degrees Fahrenheit. But once again, let's assume that our bodies have adapted to handle these swings. We've also developed ways to safeguard ourselves from meteorites and asteroids. These guys will be our frequent guests. The thin atmosphere of Mars doesn't provide much protection from them. Out of all the planets, Mars would be the easiest one for us to adapt to. Our next candidates, though, are not that hospitable. Living on Jupiter, the gas giant is a whole new level of adventure. Since there's no solid ground to walk on, we've come up with some super cool ways to call this place home. Picture floating cities like gigantic bubbles, suspended in swirling gases and liquids. They're specially designed to withstand extreme pressures and temperatures. To get around, we have jetpacks and hovercrafts. Imagine floating amidst Jupiter's majestic atmosphere, surrounded by cold, windy clouds of ammonia and water. These vibrant stripes and swirls paint the planet with a colorful palette. We zip through the colorful clouds, enjoying a mesmerizing kaleidoscope. Our homes and cities are filled with vibrant colors and shimmering lights. We've even created artificial gravity zones, where we can experience a semblance of gravity and walk with a bounce in our step. But be careful. Jupiter's powerful storms can be intense. Luckily, we have advanced weather prediction technology that keeps us safe. We watch the mesmerizing light shows of lightning dancing across the sky, marveling at the raw power of nature. All this sounds pretty fun, doesn't it? Well, what about the next gas giant, Saturn? Once again, we can live in the skies of Saturn, right among its beautiful rings. Our cities are like big, colorful balloons that sparkle and shine with bright lights. Inside, we have large domes where we can freely enjoy everything this incredible planet has to offer. Instead of walking, we use special devices that make us glide through the air, just like on Jupiter. In this extraordinary place, we had to discover new ways to generate power. We use the energy from Saturn's powerful storms. These sources of energy help us fuel our floating cities, giving us the electricity and resources we need to thrive. Saturn has many moons, and each one has its own special features. We've set up outposts on some of these moons, where we can go on exciting adventures and explore their mysterious landscapes. But if living on a gas giant wasn't challenging enough, we also have ice giants in our system. Welcome to the fascinating world of Uranus. Despite the super chilly temperature of -353 degrees Fahrenheit, we've come up with clever ways to make this place livable. To create warmth, we can learn from Earth's greenhouse effect. Like a cozy blanket, we can introduce special gases into Uranus's atmosphere that trap heat. Another idea is to build gigantic mirrors to capture and reflect the sun's heat. But let's be honest, it would be quite a challenge to position all those massive mirrors just right. Our homes are designed to withstand extreme conditions. We use dense fluids like methane, ammonia, and water to build structures that keep us warm and cozy. Our habitats provide shelter from the freezing temperatures outside. We may even discover new forms of life that have adapted to the unique conditions of this icy giant. Now that would be chilling for sure. And finally, we have Neptune. It is the cool and distant cousin of the solar system. Neptune's atmosphere is mostly composed of hydrogen, helium, and methane. There's also no water, only lots and lots of ice. But that's fine with us, right? So it's time to construct habitats. Let's envision another sky city. After all, who doesn't love the idea of floating cities amidst the clouds? Imagine gazing out from your sky city, observing the mesmerizing hues and swirling storms of this ice giant. The vibrant colors of the atmosphere would paint a breathtaking backdrop for our daily adventures. We'd explore the mysteries of Neptune's moons, delving into their icy landscapes and uncovering the secrets they hold. Hey, a world where humans don't need oxygen or water to survive doesn't sound that bad. We'd soar through the skies and roam vast landscapes. The only limits we would have would be the limits of our own imagination. So stay tuned for more captivating what-if scenarios.
People haven't set foot on the moon in several decades, but the situation is going to change soon. NASA's Artemis program is going to send a few missions to Earth's natural satellite. The first astronauts might step on the surface of the moon already in 2025, as part of Artemis 3, if the current schedule holds, that is. And then the next stage will start, and it will be an even more ambitious project than sending humans to the moon again. NASA wants to construct a base camp at our satellite's south pole. Such an outpost will help the Artemis mission to break the previous record for the longest stay on the moon. So far, it's 74 hours, 59 minutes, and 38 seconds. Plus, such a camp can serve as a jumping-off point for missions setting off for deep space. According to NASA, at first it's going to be a small camp, accommodating missions for a week or two. But soon, it'll grow in size and complexity and will be able to sustain crews for a couple of months at a time. There might also be an open-top rover similar to the one used in the Apollo missions and an RV. These options can provide mobility for astronauts while they live and work at the camp. With each new trip, the level of comfort of space explorers will increase. Specialists are now developing the technologies that will help people to work more easily on the moon, far away from home. There's also hope that building such a camp can help us prepare for an even more challenging step: human exploration of Mars. For the camp to function properly, it's very important to be able to find and extract resources from the satellite's rocks and dust. These resources can include water ice, metals, oxygen, and even some building materials. It'll help to lighten the load with supplies delivered to the moon. It can also potentially allow astronauts to remain there for longer periods of time. Now, why the lunar South Pole? There are two very important reasons. First, building the base camp there will allow astronauts to have periods of continuous light from the sun. The moon is tilted in such a way that its south pole experiences up to 2 months of continuous light every year, when the sun is circling above the horizon all the time. And all this abundant sunlight can provide the camp with a lot of solar power. At the moment, NASA is trying to design a solar array that could stay more than 30 feet in the air. This way, it'll be able to make the most of the available sunlight. The second reason for choosing this location is deep craters that have been shrouded in darkness for billions of years, also because of the moon's peculiar tilt. Some of these craters haven't seen sunlight since the time of their formation. They're also known as permanently shadowed regions, and that's where scientists have found evidence of water ice. If we manage to access this frozen water and it turns out there's a lot of it there, it'll be hugely valuable for the inhabitants of the base camp. Plus, it might supply flights back to Earth, or further on to Mars. We don't know yet whether there's a lot of water in that region or whether it's free of contaminants, but NASA is going to find out. One of the ways to do it is to use Viper. This mobile robot is likely to arrive at the lunar South Pole in 2024. The Lunar Terrain Vehicle, or LTV for short, is scheduled to arrive on a mission in 2025. Astronauts will be able to operate it remotely, and it's likely to be able to avoid such hazards as rocks and craters on its own. Astronauts will then explore their surroundings either from the safety of the lander on earlier missions or later on from the base camp itself. Plus, NASA will use the LTV to conduct scientific or mission-related work even during periods of time when there will be no humans on the moon. The vehicle will play a crucial role in searching for water ice and other resources. But even though the LTV's remote-controlled capabilities are quite innovative, its design isn't going to change much. It'll look almost like the rovers that have come before it. If astronauts decide to drive the vehicle with its top open, they will have to put on their spacesuits, and that's not very comfortable. Donning such a suit can easily take hours. Plus, the duration of missions always depends on how much oxygen each astronaut's spacesuit has left. That's where NASA's RV-like concept, known as the Habitable Mobility Platform, comes into play. If this project succeeds, the RV will have a pressurized interior and life support systems, meaning passengers will be able to have a ride without their spacesuits on. This will definitely make life easier for astronauts. The final design of the vehicle isn't ready yet, but the main goal is to allow several people to live and work inside the vehicle for up to 2 weeks. Now let's have a look at what the future lunar cabin might look like. Its design hasn't been finalized either, but NASA is looking at modular and inflatable structures. It may help to create larger spaces for crews to live in. Plus, such kinds of structures are more compact and lightweight, so it will be easier to transport them to the moon. But there's one more intriguing possibility. How about a large-scale 3D printer that will use lunar soil and rock as its raw material? Such a machine might be able to produce bricks and other shapes, assembling dwellings from scratch. A prototype 3D printer is now building a test structure in Houston. Also, the first towns on the moon could probably be built in craters. They might be covered with protective materials like plastic, reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants would have to access their homes through airlock entrances dug into a mound. Bilbo Baggins would surely appreciate their aesthetics. On the moon, gravity is way weaker than on our home planet. And while it can make it easier for astronauts to walk and even run on the moon's surface, it's not so great in the long run. That's why inside the lunar base, there might be an artificial gravitational field. Without it, people would have problems with coordination, balance, and orientation in space. Plus, weight-bearing bones would lose 1 to 5% of mineral density per month. A geologist from the University of Notre Dame, who's been studying samples of lunar soil, says that rocks or dust may have a key role in protecting astronauts from radiation coming from solar flares and cosmic rays. On Earth, the planet's atmosphere and its magnetic field filter out most of this harmful radiation. But the moon doesn't have the same shield because there's no atmosphere like on our planet there. The very weak one that our natural satellite has is made up of some unusual gases that haven't been found in the atmosphere of Earth, Mars, or Venus. That's why people working there will need extra protection. The experts say that up to 6 feet of lunar material might be needed to shield astronauts from the radiation. But besides building materials and water, there's another crucial resource on the moon, and it's oxygen. NASA hopes to start extracting this gas from moon rocks. They also hope to find metals like aluminum. This could allow astronauts to live off the land, and the base would become much more self-sufficient than expected. It could turn into a resupply station for spaceships heading for Mars. But a colony on Mars would cost us trillions of dollars to construct and inhabit. It would take a long time for even one cargo ship to reach the red planet. Lunar camps are much easier to build and maintain. There will likely be direct spaceship routes connecting the satellite with Earth, and people will need just 3 days to travel between these 2 points. That's one of the reasons the colonies on the moon will be growing, developing, and changing non-stop. Let's talk about cyberpunk, a really cool genre of science fiction that started in the early 1980s. Its pioneer writers were really interested in how technology was changing society, especially with all the digital evolution happening at that time. One of the writers, Bruce Sterling, wrote an introduction to a book called Mirror Shades, which was like a guide to cyberpunk. He said that this genre is all about looking at technology in a new way, not just for science fiction writers, but for regular people too. It's like imagining a world where high-tech stuff and the cool underground culture mix together. The heroes of cyberpunk stories are mostly rebellious people who stand up against big companies and the boring mainstream. They believe in being unique and doing their own thing, even when the world tries to contain their efforts. These heroes are really good at taking things from popular culture and using them to express their own ideas and interests. They also know how to use computers to find out secret information and spread messages that go against the system. These days, cyberpunk themes are seen in more than just literature. You can find their influence in things like movies, video games, and even fashion. It does make you wonder though, could the future truly turn out to be what cyberpunk writers predicted? Truth is, all the cyberpunk literature is packed with mind-blowing technology that might just become a reality one day. Like augmented reality, for instance. Now this might sound far-fetched, but we're actually getting closer to experience AR in our daily lives. I mean, some companies are already offering such devices. Right now, they're mostly used for gaming and entertainment, but soon enough, we might use them for virtual training, education, and even shopping for a new car or checking out a house. Next up, smart clothes. In cyberpunk video games, people are rocking these stylish garments that not only look cool, but also offer some serious protection. We're not quite there yet, but smart clothes are becoming a thing in our world too. You've probably heard of smartwatches and fitness trackers, right? Well, imagine clothing that can monitor your body's movements, suggest healthy habits, and adjust your body temperature. Some fashion brands are already exploring this exciting field. Now let's dive into virtual reality. In one particular cyberpunk story, there's a feature where you can customize your own virtual reality experience. It's like stepping into someone else's shoes and reliving their memories. Now, VR is already pretty amazing in our world. We use it for medical purposes, gaming, and tourism. And here's something even cooler. Imagine being able to feel things in virtual reality. Yeah, it's called haptic technology, and it's being developed to make VR even more immersive. You could use it to control machines, learn in a virtual classroom, or even attend a concert with friends who are miles away. Last but not least, we have artificial intelligence. In a cyberpunk scenario, AI is everywhere, from brain analysis to taxis with intelligent controllers. Now, we might not have all that advanced AI just yet, but we're definitely making progress. You're probably familiar with all those virtual assistants featured on smartphones. Well, imagine them getting even smarter. AI is expected to be integrated into so many aspects of our lives, like fridges that can automatically order groceries when we're running low, self-driving cars, and delivery drones. And hey, AI is already helping companies suggest personalized content based on certain preferences. In the future, it might even help us find the perfect recipe for dinner or recommend the ideal cosmetic product just for us. Then, there's the potential for a brain-computer interface, or BCI for short. In a cyberpunk world, it's like a special connection between our brains and the internet that would allow people to virtually explore using just their minds. In the real world, scientists are already working on developing BCI systems. They can read the signals from our brains and turn them into commands. So instead of using a keyboard or a mouse, we might be able to control objects just by thinking. Right now, these BCI devices are being used in research settings, but someday they could be used to support people. They could help with regaining useful functions and improve rehabilitation. It doesn't stop there, though. BCI could also help professionals like pilots and surgeons. It could make their natural skills even better and help them do their jobs with even more precision. But, there are also some things we need to be careful about when it comes to this cyberpunk technology. In the cyberpunk world, there are serious problems to consider. One of the concerns, for instance, is that if we rely too much on technology, it might start making decisions for us. We might become less skilled at day-to-day tasks because we let the machines do everything for us. That's why we should focus on using our own resources to make our own choices. Another thing we need to watch out for is protecting our information. All sorts of security breaches are already happening all over the world. We need to make sure we have strong measures in place to keep our information safe. Science and technology are moving at an incredible pace these days. It's hard to pinpoint what the future might look like, but you surely have some sort of scenario in mind. Maybe you envision a world where robots and AIs, controlled by a handful of powerful corporations or individuals, dominate the scene with unjust power structures. Or perhaps you picture sprawling cities filled with skyscrapers and flying cars, shrouded in perpetual darkness. And maybe the future seems bleak, where only a privileged few have access to nature, while the rest struggle to make ends meet on a harsh planet. In the cyberpunk world, our planet is either on the brink of a disaster or has already fallen into complete ruin. The stories consistently revolve around dominance and control, whether it's between the rich and the poor, corporations and the market, or humans and the AI robots they create. Cyberpunk is all about systematic and oppressive inequality. It's also about a future where most humans live in a highly mechanized society that disconnects them from the rest of the natural world. In this potential future, all the amazing technologies we've created don't really improve the lives of most people. In fact, they make things worse. It's not all bad, though. Sci-fi can be more than just entertainment. It has a way of inspiring and shaping our real world. Throughout history, designers have drawn inspiration from sci-fi for inventions for things like flip phones, self-driving cars, and even the concept of the metaverse. There are also many interesting alternatives for the future. Ever heard of solarpunk? It's also a genre of speculative fiction, but one that envisions technology and the environment evolving together. The solar part is all about the power of solar energy, while the punk part puts it in the same awesome group as other sci-fi genres like cyberpunk. So what does solarpunk actually look like? Well, imagine visually stunning utopias that are all about the environment and being positive. In solarpunk worlds, they've totally sorted out how to correctly use the planet's resources, or are actively working together to fix it. It's all about coming together and being friends in the fight against a bleak future. When you enter a solarpunk universe, you'll be greeted by groovy green tech, cities that are super walkable, and tons of lush greenery. It's all about living in harmony with nature, while still rocking the latest technology. It's like the complete opposite of cyberpunk, which is all about grimy cities, greedy corporations, and fear of outsiders. Solarpunk is all about putting people first and recognizing the amazing connection between human intelligence and the Earth. One of the major influences on solarpunk is Art Nouveau. This art movement is all about embracing organic and earthly shapes, and it fits perfectly with solarpunk's vibe. Another cool reference for solarpunk is the arts and crafts movement from the late 19th century. It was all about rebelling against unnecessary waste.
Have you ever wondered how cool buildings of the future are going to look? Well, hold on tight because artificial intelligence is here to revolutionize the world of architecture. AI is a great sidekick. It can give the architects incredible new tools to create mind-blowing structures that are not only stunning, but also eco-friendly and super efficient. So let's check what our beautiful future might look like. First of all, you know how cities can get crazy busy and overwhelming, right? Well, guess what? AI is here to save the day and make our cities super smart. Imagine you're cruising down the road in your flying car. Yes, we'll have those. Thanks to AI, the traffic flows like a dream. No more endless gridlock. The city knows where the most likely crime spots are and takes proactive steps to keep us safe. It's like having superheroes on every corner. And hey, forget about trash piling up. AI makes sure waste is managed efficiently, keeping our city clean and fresh. They can act as a city manager who can optimize everything from traffic to safety and even waste disposal. They can analyze tons of data from all sorts of places like sensors and social media. With all that information, they can help city planners make brilliant decisions that make our lives better. Okay, so you stroll down the street, and your eyes are instantly captivated by an extraordinary building. Its futuristic curves and features make it stand out from the rest. And it not only catches your eye, but also gives Mother Nature a high five. You might think it was designed by a genius architect, but little do you know it was actually a collaboration between humans and artificial intelligence. Imagine having a super smart design buddy who can whip up thousands of incredible building ideas in a blink of an eye. That's what AI-assisted design software does for architects. It can generate and assess a ton of design options. They take into account stuff like the best materials to use and the perfect placement for the building. Also, by analyzing data and crunching numbers, algorithms can help optimize the building's design. They can ensure it minimizes energy usage, conserves water, and manages waste like a pro. Every building strives to reduce costs, save energy, and promote a better world. The result? Architectural masterpieces that are both jaw-droppingly beautiful and super practical. The cityscape of the future will be dotted with these awe-inspiring structures. Oh, but that wasn't impressive enough for you? Well, how about a stunning, futuristic building that seems to defy gravity? It's not made of traditional bricks and mortar. Oh no! This marvel was created using the powers of 3D printing. With the help of AI, architects designed every intricate detail and fed all the important data, like what materials to use and how the site conditions might affect the structure. AI algorithms worked their magic to optimize the design, making it both breathtakingly beautiful and rock solid. 3D printing is basically like having a magical machine that can create awesome structures straight out of a sci-fi movie, and AI jumps in to make sure these structures are not just pretty, but also strong. In the city of the future, 3D printing will become the ultimate architect's tool. It will allow them to create structures that were once impossible to build. From mind-bending shapes to intricate details, the possibilities are endless. But AI isn't just making buildings look great, it also makes them efficient and cozy. Let's say you step into a futuristic office building, and voila! The lights automatically adjust to match your mood, and the temperature is set perfectly for you. These futuristic buildings are capable of sensing and responding to their surroundings, just like you do. They control the lighting, keeping it just right for the time of day. They manage the temperature, so it's always cozy and comfortable. They even keep a watchful eye on security and fix small issues before they become big headaches. So, the smart building knows when people come and go, so it optimizes energy usage accordingly, saving the planet and some cash along the way. Now the cool thing is, all these aren't the only possibilities. How about turning skyscrapers into a vertical forest? Recently, an architect from India got super excited about the power of artificial intelligence. So, he decided to team up with an image bot called Midjourney to create a vision for the future. But instead of a dull, robotic world, they aimed for something spectacular. With text prompts like utopian technology and futuristic towers, the architect and AI got to work. Guess what? Midjourney didn't disappoint. It conjured up a world where buildings were covered in lush vertical forests and adorned with shapes inspired by nature. They wanted to create a sustainable future that harmonized with the environment. The architect, Manas Bhatia, is super positive about AI's potential. He doesn't see it as a threat to his job, but as a powerful tool for positive change. He envisions a future where architects and AI collaborate to make breathtaking designs. In his project, Patya even asked the AI to imagine symbiotic and hollowed structures, and it responded with pictures of apartments nestled within hollowed-out trees. Imagine a world where the building itself becomes a living, breathing part of nature. Well, Bhatia believes that nature should play a big role in architecture. He loves designing structures that embrace nature's beauty and functionality. From buildings built around trees to facades that regulate temperature, he's all about blending architecture with the natural world. With architects like Bhatia and the superpowers of AI, the future of cities is going to be amazing. So get ready to step into a world where nature and technology coexist in perfect harmony. It's a dream we can't wait to see come true. Or, if you're not a big fan of trees, how about this? Skyscrapers that aren't made of solid bricks, but instead, they're inflatable wonders. Zumo, an architectural practice in Barcelona, used the magic of AI to bring these wobbly structures to life. These inflatable superstructures rise above future cities like illuminated balloons in the sky. Here's the best part. These inflatable buildings have sustainability superpowers. You can pump them up to towering heights, flatten them for easy transportation, and rebuild them wherever they're needed. Plus, they're powered by renewable energy, reducing their impact on the environment. Pretty cool, right? Phew, the future is zooming toward us like a rocket. Artificial intelligence can become the secret sauce that makes architects' work extra special. But hey, with great power comes great responsibility. We need to use AI wisely and ethically. For now, we don't have to worry about machines replacing architects. Artificial intelligence still needs a human hand, or else we might end up with buildings that look like mashed up bananas or ice cream cones, unless that's your thing. In addition, humans have one important advantage. They, well, are humans. We need to keep in mind that artificial intelligence doesn't have emotional intelligence. It's a brainy genius, but it can't fully understand the feelings and vibes we humans crave in our spaces. So, we must remember to infuse our designs with that human touch, those warm and fuzzy elements that make us go, "Ah, I feel right at home." And let's not forget that AI is still learning. It's basically just taking its first steps, and we need to be patient and give it time to grow. Rushing things too quickly could lead to wonky designs or buildings that look like a jumbled puzzle. This might look cool if you like avant-garde architecture, but for regular folk, no thanks. So, as the future unfolds at warp speed, let's embrace the wonders of AI in architecture. But let's also remember to balance its brilliance with our own human touch. Together, we can create a future where buildings are not just functional, but also filled with heart and soul. It's an adventure that's out of this world.
Humanity will once again visit the moon. The mission is planned for 2024. In this crew, we'll see the first women step on the moon. The main goal is to establish a lunar base for continued research that will help NASA prepare for an upcoming mission to Mars. Has been planning a crewed flight to the Red Planet set for the 2030s. Robotic rovers did a good job exploring the Martian surface, but astronauts will have to dig deeper to find evidence of water and any fossils proving microscopic life was once possible on our planetary neighbor. New data on Earth-like planets. Since its launch in 2009, the Kepler Space Telescope has discovered lots of exoplanets orbiting distant stars. Some of them have an Earth-like mass, composition, and orbits. NASA plans to launch a new generation of telescopes in the 2040s. They'll help us find real twins of our planet and even get pictures of their surfaces. The return of Halley's Comet. It'll be another 41 years before we once again see the most famous comet in the sky. Halley's visits us every 75 years, so some will manage to see it twice in their lifetime. The longest solar eclipse. 166 years from now, I'll still be around then, the sun will go dark for 7 minutes and 29 seconds. This is pretty close to the predicted maximum. It'll also be the longest eclipse human civilization has ever witnessed in its 10,000 years. Arrival of the most notorious asteroid. 1950 DA was once the most probable candidate among near-Earth objects we know to actually strike the planet. Fortunately, the chance was later estimated to be not even 0.1%. It'll most likely pass by on March 16, 2880. Mark your calendars. and it'll become a solid evidence that we're safe for a while. The asteroid is more than a mile in diameter, enough to take out life on a planet. A new North Star? The Earth spins like a top. Watch one of these toys closely, and you'll see how its tip starts to draw circles in the air. The Earth's axis, an imaginary line going through the poles, goes full circle once every 26,000 years. It points at different stars along the way, thus changing the North Star. By the year 3000, the Gamma Cephei star will share this title with Polaris, as the Earth's axis will point right between them. The first near-Earth supernova. Antares is the 15th brightest star in the night skies. It's also an old red supergiant, 12 times larger than the Sun. Stars this massive age to a point where they collapse in on themselves, producing huge supernovas. For Antares, this will happen just 10,000 years from now, which is nothing for a 12-million-year-old star. The resulting burst will be too far away to affect life on this planet negatively, but the light show will be visible here on Earth even during the day. Message to the universe. Delivered. Arecibo is the encoded message describing humanity, life on Earth, and the advancement of our scientific knowledge. It was broadcast from the Arecibo radio telescope and aimed at the center of the M13 cluster, 25,000 light-years away from us. In 25,000 years, it'll finally reach its destination. A new closest star. About 36,000 years from now, the Ross 248 star will become our new closest neighbor. It'll be just 3 light-years away from us and overtake the title from Proxima Centauri, which is a bit more than 4 light-years away. Ross 248 will remain the nearest star for around 9,000 years and then move away once again. So, you didn't like the neighborhood or what? The first interstellar human-made object. In 40,000 years, Voyager 1 will reach a point within 1.5 light-years of the Gliese 445 star. It successfully reached interstellar space in 2013. But, unfortunately, it won't be able to power up any of its systems somewhere beyond the year 2025. Voyager 1 has a message too, a recording of greetings in 55 languages, music from classical to rock and roll, and sounds of the Earth's wildlife. A bare Saturn. 100,000 years from now, Saturn will lose its beautiful rings. It'll happen gradually over time as the planet's colossal gravity pulls rocks and ice from this belt floating around it. They'll all eventually fall and get crushed and burned by Saturn's atmosphere. Well, how rude. The ring system is in the middle of its life cycle, so we're incredibly lucky we got to see it in its full glory. The most frightening supernova. The WR-104 star will burst into a supernova in 3,000 years. This star is 75,000 light-years away from us, and the blast won't touch us at all. But there is a small chance it'll also produce a gamma-ray burst in the process. If this stream of energy happens to aim right at us, it will negatively affect life on Earth. Good news? Scientists say that's very unlikely. Colliding moons. The moons of Uranus are part of a highly unstable system. Some of them have orbits that cross paths. Uranus already has 2 rings of debris from past collisions of its natural satellites. Desdemona and Cressida will crash into each other in the next million years and produce new rings. A star too close for comfort. The rogue Gliese 710 star is approaching our solar system, and it will get just 1 light-year away in 1.3 million years. This won't have a major impact on the planets, but it could disturb the so-called Oort cloud, which surrounds our solar system and is full of comets. From Earth, the star will look like the brightest planets we see now, and we'll see many more comets in the skies. The closest star to ever go supernova. Within a few million years, the Spica star, which is only 240 light-years from us, will burst into a supernova. Supernovae are a problem for life when they're 3 times closer than that, but the supernova itself will shine in the Earth's skies as bright as a full moon. A time capsule for future generations. The Lagios 1 satellite was launched back in 1976 to gather information about the exact shape of the Earth and tectonic plate movement. But it also contained information about civilization on Earth at the time. It'll re-enter our atmosphere in 8.4 million years. If humanity is around then, they'll learn how life on Earth was in our time. Well, at least how it was some 40 years ago. Rings for Mars. Mars' moon, Phobos, orbits really close to the surface, and it continues to get 2 feet closer every century. 50 million years from now, it'll collide with Mars, resulting in a massive amount of debris going into orbit and forming a ring system around the red planet. Oh, can't wait for that. Days on Earth will get longer. No, really? 1.4 billion years ago, the Moon was much closer to our planet. It made the Earth rotate faster, so the day was only 18 hours. The Moon is continuously moving away from Earth. In 180 million years, we'll gain 1 extra hour. In a little over 2 billion years, a day on Earth will be 36 hours long. No more solar eclipses. 600 million years into the future, the Moon will move away from the Earth too far to cover the Sun during eclipses. Those will become ancient relics. The Sun will get too bright. It'll take about 1 billion years for the Sun to raise its luminosity by 10%. This will be devastating for planets in the solar system, and life on Earth won't be possible beyond this point. By then, our species will likely have found a new planetary home. The Sun will swallow the inner planets. In 5 billion years, the Sun will begin to evolve into a red giant, growing hundreds of times its current size. It'll swell up so much, it will eventually engulf Mercury, Venus, and possibly Earth. The new Goldilocks habitable zone may shift to the orbits of Jupiter and Saturn. This process will take a bit under 3 billion years until the Sun reaches its maximum size. After that, our star will shrink into a white dwarf. The most epic event ever. Around the same time our Sun is swelled up, the nearest neighboring galaxy, Andromeda, will come too close to the Milky Way. If we could watch our galactic neighbor at this time, it'll get larger and larger as it approaches. Then, the two galaxies will start to merge. Bright blue stars will burst into life. New constellations will form. The two spiral galaxies will now be a single giant elliptical one. Wow, I've set an alarm on my smartphone so I don't miss it.